Hello there. I am Mike Nebling. I'm your instructor. I am a professor, an assistant professor to be precise, at the University of Michigan, where I work in the School of Information. I thought I should introduce myself and tell you maybe a few things about myself before we go really into this XR MOOC specialization. So I've been working in this space for about 5 years now, I would say. I've been doing research in this space, specifically in the area of human-computer interaction. And I've been teaching in the residential program at the University of Michigan for 3 years now, 2 AR/VR courses, one focused really on design and one focused on development. This is in many ways an update of the teach out that I've done a few years ago with a few of my colleagues. It was the augmented reality, virtual reality and mixed realities teach out from the University of Michigan. Maybe you've seen me there. It was great to meet some of the learners in that MOOC. And many of you have actually said, we wanted to learn more about design and development. So we've heard you and we've added significant content in both of these areas. Right, so I care about XR. You guessed that. It is really important for me that we all understand these technologies. They are making it into our everyday lives. They are there. They're not going to go away. We still have an influence on how to shape those technologies so that we have a better control, right, how these technologies make it into our everyday lives. In any case, it's time for me to pay back and pay it forward. So I hope what you learn here today is something that I had to learn myself, not just today, but over the next few weeks. It's not going to be that fast. Almost tricked you there, right? And I hope that you share that knowledge and that you invite other people to also learn about these things. Not everybody cares about development. Maybe some of us care about design, hopefully even more. And then a lot of us should really care about where this space and these technologies are going. And we should have some critical discussions about this. So, thanks for letting me meet you and joining me in this effort of spreading the knowledge around XR. And I really look forward to seeing you in the course. Hope we get to interact with each other, maybe perhaps even meet in person one day. That would be exciting. Hello and welcome to the XR MOOC. Welcome to this course on augmented, virtual and mixed reality, specifically how to develop for these kinds of exciting new technologies using WebXR, Unity and Unreal. So this is really the course that is looking at these technologies from a more technological angle. It is only one of the courses we have as part of the XR MOOC specialization. It is the third course, to be precise. It is the one that kind of assumes you have the foundational knowledge that I otherwise established in the first course, really about the concepts and the technologies in both VR and AR, and then also the key issues. And so in this course here specifically, we're going to learn how to develop applications, and we're going to learn about all the principles. And I'm going to walk over the main ingredients of the course, some of the highlights. Let's look at this course together, and I hope you will join me in this journey of developing AR, VR, and mixed reality applications. This course is really structured into 4 main modules, starting from development approaches, like really what are the different ways of creating AR, VR experiences, what are the paths to being an XR creator, given your background and experience, and an introduction and overview of WebXR, Unity, and Unreal. That's something you will find in here. Also, making the jump from 2D to 3D to really set the foundation for what is to come. We will then focus on VR development. We're starting from design. We're learning about navigation and menus in VR, and we're also going to learn about object selection and manipulation. We're going to learn about creating basic and then immersive VR experiences that do require more effort and more technology. We will also then learn about AR development. We're going to look specifically at marker-based and also marker-less approaches. So marker-based, usually Those are some of the popular markers, Vuforia, and this is AR Toolkit and ARJS, so part of WebXR. We're going to do all these things, and we are going to, in the end, cover what I call here special topics. So that would be advanced techniques. I'm going to talk about XR research, and I'm going to also show a little bit of the making of this MOOC because it'll showcase a few techniques that I've used to actually bring these technologies closer to learners in remote settings. I hope I was successful. I hope you enjoy the content I put together. Trust me, it was a lot of work, and I hope it is visible and that you enjoy the content here and that you feel like you're learning a lot. That would be my dream. So in terms of learning, we then have quizzes, so you to assess your learning and making sure, well, for you to make sure that you feel like you're on track. And so we have quizzes after each of the main modules. We also have a lot of content as part of the honors track, specifically exercises that help you really develop a systematic approach to developing 3D, VR, and then AR scenes. We have a few major examples throughout this MOOC. One is a case study focused on virtual reality design. This one is modeled after after an example that I started creating in one of my online office hours that I streamed on Twitch. It was modeled after the Detroit Zoo, and it became really this project that was then developed further by one of my students, Kara Daly. She really helped bringing this to life and adding all these things in, making it a night safari, including a petting and feeding area, which we can only do in virtual reality. So in the honors track, you will then create your own 3D scene. It could look like something like this initially, and then you could take it further and make it a virtual reality scene. So here we have our giraffe. You probably don't notice, but one of the main things I adjusted here is scale. Obviously provide an environment. I also have support for virtual reality controllers, so we learn all about how to handle interaction and navigation in virtual reality. We're also going to learn about turning VR scenes into AR experiences. So here you, for example, see how I bring a, well, maybe life-size giraffe into my living room using a marker-less AR approach, and I'm going to show you a marker-based version of this as well. So here's our giraffe, and so here is the marker-based version. So obviously what we learn about is differences when it comes to marker-based and marker-less AR, how tracking works, how we should design differently, how interactions work differently. So throughout the course you will learn about the XR process. You'll learn about not so much need finding, brainstorming, storyboarding, and prototyping. These are key ingredients of the XR process, but they are in the focus of the second course as part of the specialization. This course focuses on development and testing. It does really go deep there. And deployment and analytics is really also something that is kind of like covered in the second course. So the way you should look at this is this MOOC really goes deep here, and it's embedded into the larger process that is ultimately covered by this entire specialization. I also care really about my students, and I always think about different ways for them to really get the most out of this content. So how do we make this content accessible? And a lot of us may have a web design development background, maybe not even. Some of us may already be familiar with game design and development, so then tools like Unity and Unreal feel like a good fit. And some of us may have previously designed mobile applications, and now we are very interested in how do we translate this knowledge. So for the web developers, we're going to talk in this MOOC. I have lots of examples in the WebXR space. I cover all these platforms. We do mention native SDKs, but this is not really the focus of this MOOC. So we cover WebXR, Unity, and Unreal. For each of these, so WebXR, Unity, and Unreal, we are going to talk about popular platforms like A-Frame, ARJS, DMVR, MRTK, Vuforia, AR Foundation, XR Interaction. So these are popular examples. We also learn about popular AR and VR devices. So here I list VR devices, here I list AR devices, including the webcam. If you think of the webcam as an AR device, given that it is the means to do marker-based AR. And We'll also learn about how to assess some of these technologies, how to map these toolkits to platforms and to the specific devices. And then with that knowledge, we're really gonna learn about the process. And in this course, we are trying to make this jump into 3D so that we can then, so as quickly as possible, actually in week 1, so that we can then actually explore learning about VR and AR by doing projects in that space, at least as part of the honors track. And then topics-wise, I'll cover all the important key elements that help us create immersive VR experiences, and then we learn also about how to do marker-based, markerless AR experiences for handheld and then also head-worn. In the first module, we're gonna spend quite a bit of time to make the jump from 2D to 3D. So we learn about coordinate systems, we learn about how rendering works, a perspective camera, the fact that light is required, the fact that there are 3 axes, so X, Y, and Z. We're going to learn about object transforms. We're going to learn about all these concepts and principles in a way that is tool agnostic, and then you will be given the opportunity to obviously learn it in your tool of choice. So we will cover things like the perspective camera so that you know how a 3D scene is rendered, how virtual cameras work, and then how that knowledge translates to VR and to AR. We're going to start with all the key things. We're going to learn about ray casting and hit testing as a way of determining where people are pointing, enabling object selection, enabling object manipulation in VR. We're going to learn about different kinds of menu designs. Here I show one of the latest examples, a hand menu. It's pretty cool. Implemented on the Oculus Quest, so it's in the Oculus browser. It's done in WebXR. We're going to learn about pass-through a little bit and how hand tracking is now possible and becoming a standard ingredient in VR devices. We'll focus most of our attention on handheld AR, but we're also going to learn about head-worn AR and the additional capabilities that a device like the HoloLens 2 would give us. So here, for example, I'll show the spatial mesh in real time as it is recognized, and how it is used for occlusion and how it can be used for physics, so that these cubes can then actually really land on, for example, my table there. So devices wise, obviously we will cover a lot of the devices, but it's too many out there to go over each of them. You see some in the background. So I do work primarily in this course, I work primarily with the HoloLens 2 and the Oculus Rift S. But I realized that not everybody has access to these devices, and that is fine. We will also work a lot with cardboard, so that would require a mobile phone going in there, and that's something we will do. And then we can actually, destroy cardboard to have the camera exposed, and then we can also do augmented reality with cardboard. We can also obviously use some more specialized cardboard AR headsets like the HoloKit. If you haven't seen this, I like this one, it's actually pretty good. And we're going to learn more about AR. We have a whole case study on AR contributed by one of my students, Shweta Rajaram, and this is a Kepler's laws of planetary motion example where we're using marker-based AR, and I think in a really cool way because we're really making use of the paper. We also talk about the transition from marker-based to markerless and vice versa. So for augmented reality, that changes quite a bit in terms of the interaction, in terms of the user experience. Users have to care less or pay less attention to where the camera is and go more intuitively about the experience, for example. We're going to go back in this course really to going really low level sometimes to really understand how does this stuff really work behind the scenes. So how does marker-based tracking actually work? I'll walk you through the pipeline. We're going to also learn about obviously some of the latest toolkits out there. So on top of AR Core and AR Core in Unity, you have AR Foundation. Here I show an example of how they read the environment, and so that is something that we'll learn about, how markerless AR works. We're also going to learn about the affordances of AR technologies. Obviously challenges of blending in with the environment. One of the things that used to be really hard is rendering occlusion. Here I place a few objects behind this chair, And they are indeed occluded, and this is possible with the depth API on AR Core. And then finally, some of the latest features really allow us to make sense of the scene and the content that the device sees. So here I show a virtual vase, and it should be occluded by my hand, and then when I'm behind it, it should actually occlude my hand, and so that is very interesting. And ultimately, in the end, I want to show you one of the cooler AR experiences that I have tried out right here in my studio, which is Mission AR. It's an Unreal project for the HoloLens 2, and it is actually really quite immersive. Even though we would normally speak more of immersiveness when it comes to virtual reality, but this is really quite well done for augmented reality. I'll also at the end cover some more advanced topics like procedural generation, which I think is pretty cool for more open-ended virtual reality applications. We're also going to learn more about advanced topics in augmented reality, like 3D reconstruction, which then creates a spatial mesh, reading the environment, and then also doing object recognition like this table here, which requires semantic classification and labels so that we actually know we're looking at a table. Once we do, we can actually do interesting things, and these ideas are now becoming more or less a standard in the latest toolkits. Finally, I'm going to talk about XR research. So I'm going to explore a few topics, at least the ones that I think are popular and going to be interesting for the next few years. From an HCI, a human-computer interaction perspective, I talk about skills that I think students will need to participate in XR research, which include obviously user experience and design, so human-computer interaction research skills, obviously AR/VR technological skills, and programming is one of those important ones. And then actually the ability to do research. And because of the cutting edge, or let's say really bleeding edge nature of AR/VR technologies, this is really the part where all these skills come together. So a research approach to this whole field of XR is actually a very good approach. Finally, we're going to talk about good and bad questions to ask when it comes to XR research, at least my opinion. And throughout this MOOC and all my MOOCs, we are going to emphasize, not always sufficiently addressed, but at least emphasize really important design issues like social and ethical concerns, as these technologies are becoming more mainstream, more pervasive, and making it into our daily lives to some extent. Yes, really radically changing daily life, accessibility and equity. And equity is really a big issue. We will probably notice this a lot also in this course, just for practical reasons, such as you not having access to, for example, the HoloLens 2, or even some markerless AR solutions like ARKit and AR Core, or a virtual reality headset. Accessibility is a pretty big concern, and it's actually really poorly addressed so far. Finally, we're going to talk about privacy and security. But again, I would refer to the first course in this XR MOOC specialization, which really emphasizes these issues and provides a platform for discussion about these issues. In this course, we're going to be so busy working with these technologies. I mean, putting this on your head and giving a demo and learning about how this works is really one thing, and is fundamental. And that is like where this course really sets the emphasis and the focus. But what does it mean that this device sees everything we do in the environment in which we use it, including people that may be around? And so it is important, while this course focuses on all these technological issues and how to get things running, we'll just be glad if things are running. But it cannot end there, even though the course obviously that's the scope of the course. But please then add to your portfolio by also considering taking the other courses that are really, really important, focused on design thinking and design doing and a lot of the issues. So let's get started in this course. Hopefully it's an interesting course for you. It is a different approach to learning about these technologies by doing and really doing, getting our hands really dirty this time, doing XR. In this course, we're going to talk about XR development. Before we really get started, we're going to explore different alternatives and different routes to being an XR creator. I'm going to introduce you to 3 platforms or tools, if you will: WebXR, Unity, and Unreal. Those are the 3 big options that we're going to cover throughout this course. I have a lot of experience with WebXR and A-Frame. So A-Frame is our web-based approach, and that leads us into WebXR. And then Unity you may have heard of. So a lot of people that talk about XR swear on Unity. And then Unreal, I mean, if you've played some games and you've heard of Epic Games, Unreal is really the tool that was and is behind many of the games that are being created by Epic Games. And so it's actually really a powerful tool. So we're going to explore all these 3 throughout the course. Most of my experience is, as I say, with Unity and A-Frame, at least at this stage. But I'm always learning. And that's also the point of this whole course, right? We're going to learn more about XR development together. So I'm going to show you an overview first. So the XR process, and this is something that I've talked about also in the second course, more focused on design. So might be a little bit of a repetition if you have taken this course before. But so in that other course, we're going to talk a lot more about need finding and brainstorming as really one of the first big steps that we have to do as part of the XR process. We also really heavily emphasize storyboarding and prototyping. The whole second course was really focused on that. Now in this third course, as part of the XR MOOC, we are focused on development and testing. That is really our goal here and our whole focus of this course. So we're going to be a bit more technical. And we also normally, as part of the XR process, well, when we're done with development, we need to figure out how to get this stuff to the user. So let's call this deployment. And you would probably think you're done then, but actually, this is where a lot of the work really actually just gets, started in the form of analytics. You want to find out whether what you have actually makes sense. So this is not the first time you do user testing, okay? Don't get me wrong. By that time, you should have already done user testing. In fact, we do user testing. We involve users throughout, okay, in each of these steps. And I've introduced you to various techniques, even down to paper prototyping and testing. Even at this second step. And development and testing also should and can involve users as much as possible. So the analytics part is something that I'll talk about at the end of this course as part of some of the more advanced techniques. Throughout the course, we're really here. This is us. This is all we're going to do if you think about it. There's so much to talk about. So things you should do first, and I say this, as a piece of advice, but also like what that means, given where we are in the process. So you should have a plan, a project plan. You should have defined your approach, and I'll tell you a little bit more about the development approach in this lecture. There should be milestones defined, and you should have roles. Usually it is probably more than one person working on an XR project. But if it's just you, then, well, good luck. No, I mean, that's pretty cool. I've done a lot of projects just by myself as well, and it's totally doable. You also should have done some sketching, so both high-level and detailed sketches. You should have fleshed out your ideas. You should have a better idea of the personas. So who are the people we are actually designing for and who we are not designing for. And then usually what we do as part of a more user experience and interaction design oriented process, we do story maps. We identify the goals and tasks that we want to support. I know, talking to you now as developers, you probably primarily think in terms of features. What kind of features should I develop? What should I implement? How do I implement those? I usually like to think in terms of goals I want to support, so users' goals, and then what are their tasks and activities, and that then informs the features. And actually, to learn more about the features, we usually do prototyping in 2 rounds, physical and digital. And again, this was the focus of the second course. So we will revisit elements, but not too much in this course. Okay, again, well, it seems like I'm advertising in the second course a lot, but I really, really believe in this, and you should trust me on that one. So it is really significant that you do these physical and digital prototypes firsthand. and before you do any kind of major development. So here you see from our Pokemon Go kind of workshop, starting out on paper and then quickly using this template, this 360 paper template, to then prototype this way. And then we've also worked on tools to quickly digitize content, and this is an example of that. So these physical and digital prototypes, I would say they're quick and dirty, but they're really useful to explore interactions. They're important to get initial user feedback. You can actually involve users already at this stage, and you should think of AR, VR as an option. So nobody says it has to be an AR or VR solution, so you really want to avoid premature commitment. On the other hand, if you feel like XR approach is the right thing, then these prototypes will definitely also tell you more about the technical requirements and help you devise those. So what we should also understand throughout, and I've really talked about this again more in the second course, but we are going to approach development also in stages from low fidelity to high fidelity. So we're going to work with placeholder content. You can do this in digital tools. We work with 3D primitives, like here the sphere in the back, the box, and the cylinder. So those guys. And then you would polish your content. Usually this is some kind of fancy 3D model. And then we're going to actually add support for implicit and explicit interactions. I've introduced those terms before. So implicit interactions are mostly kind of like camera based. So that would mean here this is relatively simple in a 3 degrees of freedom headset like cardboard. There's not too many things you can do. You do have a button, and I would call this an explicit interaction. The user is actually targeting something and then explicitly clicking. Now we do gaze on a lot of things as we gaze around, so these are all implicit interactions. If you dwell on something or fuse in on something, I would then call this an explicit interaction. And this is the example I'm going to give here. So let's assume the user is gazing onto this object, and then they're like staying there. We call this fuse. That actually triggers a click event. And well, we've just changed the 3D model, the appearance somehow. We've manipulated it. So I would recommend that you start on the lo-fi end. You plan out scenes with placeholder content, and then you can bring in some of the more, well, the nicer 3D models and the content that you need, including audio and all those kinds of things. And then, only then, we are actually doing interactions. Now, the way I say it here, it sounds like very sequential. A lot of this is really iterative. So development and testing. So this is a figure I've shown in the second course as well. So here we see the three kind of big approaches that we're going to talk about. WebXR. When I say WebXR, it will be a little confusing. Sometimes I really specifically refer to the WebXR specification, so it's really an upcoming standard. And sometimes we just use WebXR as a term to loosely refer to doing AR, VR things on the web. So speaking of doing AR, VR things on the web, I think A-Frame is a really cool tool for that, and that's the one that I've chosen. So I think of A-Frame as the tool to do WebXR throughout this course. Okay. We're also going to do Unity and Unreal in this course. I have more experience with Unity, I just must honestly say that, but I have been practicing my Unreal skills through a learning group in our lab that was really cool, organized by one of my students, Alan. He did a really good job. And then also we have actually attended a few workshops by Epic themselves, so they have been very supportive of us here at Michigan. Anyway, so with Unity you can do things like Steam VR, which is cross-platform VR development. So cross-platform means you can reach all those guys, Oculus and Vive and others, Valve and the Index and other kinds of headsets that I don't always list here. You can also do AR development, so AR Foundation, which is kind of like a cross-platform thing above ARKit and AR Core. Okay, so native SDKs are like when you're good at mobile development, for example, then these are the specific SDKs. You target Oculus directly, or you target Vive, the HTC Vive directly, or you target ARKit directly, or you target AR Core directly. So AR Foundation specific to Unity. And then MRTK, so Mixed Reality Toolkit, is really one of the toolkits that I've been playing around with a lot recently. It allows me to do both mobile AR and then also HoloLens development. So I'm really fond of the HoloLens 1 and the HoloLens 2 actually quite a bit. And so that gives us an overview of how you could do development and then testing. So each of these actually then come with specific tools for testing. So in A-Frame, for example, there's an inspector that helps you a little bit. Unity and Unreal obviously have debugging consoles and a lot of notifications and additional tools. And then don't get me even started on Android Studio or Swift and Xcode if you're doing, for example, AR. There's a lot of developer tool support in there as well. And you probably know that better. If you are choosing this route, I can't help you. You probably know better, and maybe you are actually too advanced for this course. What we're going to do here is I'm going to show you the paths to being an XR creator. So we have the three main approaches down there: web-based, cross-platform, and then native. And so if you have a web dev background, well, guess in a second you probably guessed it right. Yes, this is the right path. You're onto something. And I'm going to show you, if you have a game development background or a mobile development background, the ideal path, or the easiest, the path of least resistance will be actually always going down straight. So I've sketched this out here as easy and hard. So I think of web dev picking up, if you know HTML, CSS, and JavaScript, picking up, for example, A-Frame, that's going to be doable. Picking up 3JS, you really have to be good in JavaScript, I would just say that. And ARJS is really super simple. If you're a game developer, then this path is probably a good one. You might already be very experienced with Unity and Unreal, and then all you have to learn is these XR tools down there. What I don't show here is XR Interaction Toolkit as part of Unity as well. It's kind of like a Steam VR. It's more of a recent thing, and I show you some demos of it. And then mobile development. So here you're going, you can actually do both. I mean, if you're a mobile developer, then wow, you can probably do the native SDKs because you're used to this, and Android Studio is no problem for you, or Xcode, and you understand all that. So Oculus and Vive, you would probably still go through Unity, to be honest. In any case, as a mobile dev background person, you shouldn't have any problems picking up either way. I would like to see you go this route because it'll introduce you to a lot of a really healthy ecosystem around XR. I've already talked quite a bit about WebXR, Unity, and Unreal, and the differences between each of them. Maybe Unity is still very dominant in not only in the game market, but also in the XR space. Now, WebXR and Unreal are also really actually great tools, and obviously the web is evolving. It's kind of like this native versus mobile war, where the question was, should I do a native, so an Android or iOS app on my mobile phone, or should I use web technologies to create an application, a mobile application on the web? And we have seen various different kinds of tools. And so I would say with WebXR, it's the same. It's going to be the same thing. We will see lots of actually approaches and lots of solutions going through the web, and that will push both the browser support and then also what we can actually do. Anyway, Unreal is really the beautiful kind of approach to XR. A little bit behind at this stage, behind Unity, but I mean, these are great people. We work with them. they're really onto something. I think this will be quite a match between the two. So let me go back a little and compare the web versus A-frame. So when you think of web development, okay, so you use HTML to define the structure and content, right? The organization of the page content and the hierarchy. So it's a DOM tree, but not only, because we can also obviously control the presentation through CSS, cascading style sheets, and they define the page content presentation. And behavior we usually do in JavaScript. So how does A-frame now compare to all this? How does this change? So first of all, I would say with A-frame we're talking about entities, components, and systems, and then also scripts. So ECS, Entity Component System, is really an interesting approach to developing applications. It's very data driven. And so what that means is you define the structure. We call this the scene graph, or in Unity it's called the hierarchy. We define that in entities. And then each of these entities, like a box, a sphere, like all the primitives you have in a scene, and maybe a plane that they stand on, or some kind of environment, and then maybe some light, and then maybe some camera. These would all be entities, but they are all entities with different kinds of behavior and also content and presentation. Actually, they have a variety of different components usually associated with them, and they define the 3D scene content and presentation. They also define the type of the entity really a lot more, and basically their functionality. And behind these entities and components is usually some kinds of scripts functionality that is triggered. They specify the interactive behavior. So for example, their particle systems and physics systems are like entire systems that you can load on top of an A-frame or a 3JS scene, for example. So I also just said A-frame, 3JS, and WebXR, and so many terms. So let me visualize this here. So down here we have the web layer, okay? Ta-da! And next, I'm going to show you where WebXR sits. So WebXR is kind of like a JavaScript extension of the navigator object in the browser. And that gives us access to a variety of things, including, for example, requesting the start of an XR session. And then A-frame is up there. So A-frame is really like, instead of div and whatnot in HTML, you would still write HTML tags. Actually, you will have HTML tags. A-frame introduces a number of new tags. We call this markup tags. So A-entity is kind of like the most generic kind of tag type. It's kind of like a div in HTML. But you have also more specific shortcuts, if you will. So you could write a box, a sphere, a cylinder, and these give you then entities with specific geometry and actual material as well. So WebGL is actually the web extension for rendering graphics, including 3D graphics on the web. And so an A-frame scene actually includes a canvas, and that canvas is a 3D context, and that is actually rendered and manipulated through WebGL functions. And 3JS, because nobody really wants to do this with JavaScript themselves, 3JS is really one of the most popular widespread libraries out there in the web. That is a 3D graphics library, and it's JavaScript. So really it is JS, it is just a JavaScript layer. And now A-frame actually comes in and provides a declarative web-based framework. So WebXR is then a standard that is currently being developed that enables XR applications on the web by allowing pages, so web pages. Really, that's what they are, HTML documents to call JavaScript functions, to detect XR capabilities, to query XR device capabilities, and to poll XR device and associated input device state. So really figuring out what's going on. Do we have a 3 degrees of freedom or 6 degrees of freedom headset? What's the motion controller? Do we actually have a motion controller? Is AR or VR supported? So that would be more like in the query part. And then display imagery, and I mean both like visual and audio on XR devices at the appropriate frame rate. And the workflow is usually, well, asking at the beginning when the document loads, is XR mode supported? And then we can, depending on which modes are supported, might be just VR or just AR. And usually you see VR, and then you also on AR capable devices, so there are those that support ARKit and AR Core, you would see this button. So then when the user decides to click one of these, so enter XR mode, this needs to be a user function. The user explicitly needs to trigger this event. You request a session with that specific mode. You actually have much more fine-grained, so different types of modes. So is it AR, is it a see-through, or is it some kind of magic window style? So there are different kinds of things. You could request this, and then establishes this render loop. So it's rendering all the time, like all the cool stuff that we see in AR and VR, until the user decides to exit, and then we end the XR session. So I've introduced you to WebXR, Unity, and Unreal, and I've told you more about WebXR, and I explained why A-Frame and how that relates to WebXR and actually 3JS and also HTML, CSS, and JavaScript, so the whole web layer. And now let's compare Unity and A-Frame. So Unity is actually a game engine, but it is also now grown into an XR development platform. In fact, it's the de facto standard for XR apps. I would say that many XR apps, so AR and VR apps that you try out, were probably done in Unity. Unity actually has increasingly built-in support for XR. So the XR plugin and the XR interaction toolkit, as well as AR Foundation, are all part of Unity, the whole ecosystem of Unity. So most XR people will ask you about your Unity skills before they consider hiring you. Nobody at this stage is going to ask you, so what's your experience with WebXR? People may ask you, obviously, how do you think about Unity and Unreal, and what's your experience with both these tools? And often, it really depends what people are after. So for example, in my interactions with Disney, it became really clear that Disney really swears on Unreal, almost doesn't do anything in Unity. I mean, they've done some things in Unity, but most of the recent stuff is done in Unreal. And that just has to do with the graphics, the visual quality in Unreal that is still really, really amazing. But when it comes to XR, yeah, maybe we don't actually need that yet, and we can get away with a lot of different techniques, and Unity is actually really well equipped there. So it actually supports all kinds of AR, VR devices. Every vendor provides a Unity SDK. And A-Frame is a declarative WebXR framework. It actually is more or less in line with the WebXR specifications, so I don't say it loosely. So it is Web, AR, and VR. It started out as VR only, and then it became more and more AR through ARJS, which was really a library developed separately, but it's kind of really popularized also A-Frame because that was the most accessible way. 3JS is really, as I said, A-Frame sits on top of 3JS. A lot of my students really like A-Frame, at least in the beginning. And then when you create something more complex, it becomes a little tedious unless you really know your way around in these tools. And that's what I'm also going to talk about. Finally, in A-Frame, we have support for most XR devices. So we have full WebXR support in Firefox. So when you see me code in the following lectures, and I then just press the VR button and it goes directly into my Oculus headset, then I use Firefox. Chrome, not on desktop, Chrome on mobile. So when I show you things on my mobile phone, I usually use an AR Core capable Pixel phone, and then I'm running Chrome there, the Chrome web browser. At this stage, you really have to pay attention to which browsers you're using on which devices. If I'm showing you an example on the Oculus Quest, I'm actually using the Oculus browser. So for Rift S, I'm using Firefox. For Oculus Quest, I'm running actually the Oculus browser inside the Oculus Quest. When I show you later also maybe perhaps some HoloLens examples, A-Frame can also be used to actually get content onto the HoloLens. At this stage I'm using Edge, which is the inbuilt HoloLens browser, but since Microsoft kind of like abandoned the whole Edge and Internet Explorer thing and is now in the process of moving towards Chromium, which is also behind Oculus browser, these browsers will all be, well, unified in some sense and will all provide support, and one day I can actually say all XR devices. So Unity versus Unreal, that is a tough one. It really depends who you are. I personally, as I said, have more experience with Unity, but that's just like because Unreal, at the time when I started, Unreal wasn't actually that well equipped with XR things, and Unity was really like ahead, and that's why I have more experience with Unity. And so I'm going to try to answer this, which one is kind of better, by asking you kind of 4 questions, and those 4 questions you should ask yourself. So the first question is, what level of visuals are you after? And if you're after a high quality visuals, you would probably often just pick Unreal. Unity won't produce quite the same quality. They are getting better. They have this scriptable render pipeline and HDR extensions and all kinds of really interesting things. So, but at this stage, people would still say that Unreal is higher quality visuals. I would ask you whether you're a developer or a designer. I would say if you're a developer, you may prefer Unity. It's just something that I have seen with a lot of my students. And then if you're a designer, I think you might lean towards Unreal. And that is because, at least initially, Unreal has a lot more visual scripting facilities. They call them blueprints, and we'll talk about this a little bit. And while they look more intuitive and accessible initially, they're actually, I don't know, from my perspective, because I can program, I guess, it's hard for me to say, but I actually prefer coding over visual scripting. In any case, to designers, the visual scripting approach might be initially at least more appealing. So I would say designers are leaning towards Unreal. May not be true for everybody. What is your development environment? Is the next question I would ask you. And here, I mean, based on my experience, and I actually really have good equipment, but Unity enables you to create complex projects for even low-end devices and on even low-end devices. So even on your MacBook, if you have it, and which, sorry, but in the XR space is a low-end device. And Unreal requires a powerful PC and broadband internet setup because you really have to download like everything all the time. And we're talking about gigabytes of content. It's just crazy. And so I would say this is really important. Like, what kind of equipment do you have available for development? And then if you're not super well equipped, like a studio, then Unreal will be hard. And finally, what device is your project aimed at? So what are you targeting? And here I would say Unreal supports XR, but there is actually quite a bit of overhead. So Unreal is not like this native geared towards XR platform. Unreal is really like for games and super quality visuals. Unity now actually has native XR support. So has really changed quite a bit and evolved over the last few years. So let me wrap up this lecture. So this was a first overview. I threw out a lot of terms. So to be honest, for some of these terms, like SDK, software development kit, and I don't always like provide the definitions. This is a course that is geared towards people that are thinking a little bit more technically. My previous courses, course 1 and course 2, focused on all the fundamental concepts and then focused on design, really allowed us to build some of the terminology in that space and get familiar with that language. And in this course, I'm just going to, talk to developers or those who want to aspire to become a developer. And it's just like with a different language. You don't have to understand every single word the other person says. But you have to know your ways around, right? And so Googling, not so difficult. So if SDK is something that you don't say, or API on a regular basis, which is an application programming interface, then you can ignore those terms, or you can just Google them in your free time. They're not that important. They're just technical terms. I will actually really introduce you to all the important technical terms. And we will focus on actually making the jump from 2D to 3D. That's like one of our main accomplishments in this module, in this first week of this course. But initially, to give you a little bit of a development overview, I also, like, if I scared you a little bit, that's fine. Maybe I wanted to do that. But you should really be able to take this course. So let's keep the following things in mind. There are many viable paths to being an XR creator. I've covered quite a bit in this course. However, we'll focus on 3 of them. So we're going to do WebXR, Unity, and Unreal. And when it comes to WebXR and A-Frame, I told you that A-Frame is a declarative WebXR framework. So it's actually more or less implementing the upcoming WebXR standard, and it's sitting on top of 3.js. So that's something to keep in mind. We will use this actually throughout. You will see me use a lot of A-frame, even just to introduce you to some key concepts. It's so easy for me to create these examples in A-frame, so I've always done it in my classes. I have this huge CodePen library. I mean, huge is a little bit of an overstatement, but I do have lots of examples on CodePen out there. So check those out, and I'll also link them, and then you can actually do these things in parallel as you watch me go over some of these concepts as well. A-frame, Unity, and Unreal. Well, then it's hard, really. I would say the learning curve you will experience depends really on your background. I actually picked up the tools in this way. First A-frame, then Unity, and then Unreal. I was working on WebXR projects and Unity projects almost at the same time, so WebVR with A-frame. But I found Unity so scary and so overwhelming initially, and I actually have a PhD in computer science, but the world is quite different. I've just never done a lot of Unity stuff before, and I feel like A-frame helped me go into these tools. So I strongly believe on that, and that's why I've chosen these 3 tools to making this kind of transition from A-frame to Unity, and then maybe from Unity to Unreal. Finally, there are many other tools. Or people may tell you they use very specific marker-based AR libraries, or they do anything and everything in kind of like a 360 prototyping tool like Tour Creator from Google. So lots of tools out there, but the ones that I've chosen here are actually really the ones that I think have a critical mass behind them. A-frame is a little debatable in terms of critical mass, but I say WebXR, okay? And so I do think of A-frame as a tool to bring you closer to WebXR. And one thing that is currently happening as I'm developing this MOOC is React. The React framework is actually adding more and more XR support. And so it's quite competitive to A-frame. And yeah, and 3JS obviously is still around. There are also some other alternatives. But anyway, there are many other tools out there. These are the 3 that I chose. Keep in mind that every tool has a threshold, so like a barrier to entry, and that is often quite high. And it also has a ceiling, like really like that is the upper bounds, so what you can actually do with these tools. And no matter which tool is recommended to you, they each have these, and they often trade them off for each other, right? So if the ceiling is really high, that means the threshold is often also very high. You won't find a tool where the threshold is super low, the barrier to entry, everybody can use it, and you can do everything with it. Those tools actually don't exist. Like they would be everybody's dream, but they don't exist. And that's also something I've talked about in previous courses as well. So let's get started. In the next few lectures, we're going to get our hands dirty with WebXR, Unity, and Unreal, and we're going to do VR, and we're going to do AR, and it's going to be a lot of fun, I promise. In this lecture, we're going to start building our XR development toolbox. My whole goal with this course is to, well, enable you to learn more about VR and AR technologies by building directly against these technologies. And I don't want you to do this like from scratch. Actually, there are lots of tools and toolkits out there that actually make it easier for us. And so one of the first important things we have to accomplish is getting a better overview of the space. And so this lecture, I'm going to talk a little bit about the platforms and the toolkits that we have available. I'm going to show you some examples, and then I'm actually going to talk to you more about what it means to have a toolbox. So what I think are the main ingredients, what are all the things we should put in our toolbox, and what are in fact the things we're going to learn about in more detail throughout the MOOC. Well, I would say we are covering 3 platforms. So WebXR as a platform, Unity, and Unreal. So WebXR is an evolving, and I hope soon to be fully adopted standard that brings web AR and VR to browsers, okay? So basically using the web as an implementation platform and delivery platform for AR, VR applications. Quite cool. And we're going to spend quite some time in WebXR. We're going to use A-frame as one way to program against WebXR, if you will. And with WebXR, you can reach a number of devices, and I'm going to talk about that next. Unity, pretty popular choice, lots of market share, makes sense to learn more about Unity. This is not a Unity course though. I mean, we are learning about Unity to learn about AR, VR, but if you really want to learn about Unity, you should really go to the Unity website, and they have lots of resources there. The same for Unreal. So the way I cover Unreal here at this stage is like, I want you to know about Unreal. I want you to know that it actually has increasing and really getting better at support for AR, VR. And actually in some ways I would sometimes give it the edge over Unity. Especially when it comes to immersive authoring. It's really nicely integrated, the VR support in the editor, straightforward, so I'll show you examples of that. And for the rest of this course, I probably spend more time talking about WebXR and Unity. I just wanted to make sure that our friends from Unreal know we appreciate them, and we are hoping for more collaboration and opportunities to do more with Unreal. I think it's a really great platform. So let's start with the first overview of XR platforms and toolkits, okay? So I'm going to map, in the following, I'm going to map a lot of the toolkits that we have available to the different platforms. First, we need to distinguish between VR and AR. So on the VR side, we have a number of platforms. I'm just going to read them out for now, but I'm going to have more examples and make it clearer. So A-Frame, Steam VR, Mixed Reality Toolkit, XR Interaction, and Oculus and Vive SDKs. These are obviously the native SDKs from the vendors. XR Interaction is part of Unity. MRTK Mixed Reality Toolkit is from Microsoft and works both for Windows Mixed Reality platforms and the HoloLens, but also has other support, and we're going to learn about that. Steam VR, very popular virtual reality platform and toolkit, well, let's say toolkit, that abstracts nicely from various VR devices, including Oculus and Vive. And then on the AR side, we need to distinguish between marker-based and marker-less AR. And so we have AR.js as a web-based approach to marker-based augmented reality. And then Vuforia, a popular marker-based AR library for Unity. Marker-less AR, we actually have, it looks like we have a lot more support there. Let's say it's been evolving, and there's a lot of initial support. Obviously, ARKit and ARCore are really powerful platforms. On the web, we have A-Frame again. It has an AR module, so that works relatively well. I'll clarify on the relatively part. AR Foundation and XR Interaction are, again, two things that are built into Unity. AR Foundation abstracts from ARKit and ARCore and actually has pretty good support. Whenever these come out with new features, so the Apple platform or the Google platform, it doesn't take too long before it makes it into the AR Foundation as part of Unity. Mixed Reality Toolkit really started out as Holo Toolkit, so it's no wonder it's here, because it used to be focused on HoloLens and then expanded support to Windows Mixed Reality, so the whole VR platform of Microsoft, and now it actually also extends into ARKit and ARCore, so it's becoming a relatively universal platform. And then XR Interaction is really the XR Interaction side of Unity. Both VR and AR support, and AR support integrates with AR Foundation. So what I'm going to do now is, I was just going through this very quickly to give you this first overview, but now we're going to look at each of these in a little bit more detail. I'm going to map them to the platform, and I'm going to show you which of the devices you can reach, at least at this stage. So first up is A-Frame. A-Frame is a toolkit based on Three.js and then the web, and actually integrates with WebXR. And with A-Frame, which started out really mostly as a web VR toolkit, you have support across the board for all VR headsets that I've listed here. And then when it comes to AR, well, you don't actually have support in A-Frame directly for marker-based AR via the webcam, but you can use AR.js for that. I'm going to show you in a second. And then on the marker-less AR side, I would say there is actually the best support right now. A-Frame's AR module works with ARCore on Chrome, so that is it. But with Firefox for iOS, you can actually get it to work. There's a WebXR viewer. You get it to work on ARKit, so therefore iOS. But it's not. You can't actually reach it out of the standard browser, so that is a little sad at the moment. And then it does work on HoloLens, like you can when you configure the browser on HoloLens with a few flags, you get it to work. But it's not really great support either. So here's an example of A-frame. This is what it looks like. It's one of their standard scenes, so it's like the standard assets of A-frame. It's the Hello WebVR example. It has a few primitive shapes in there. You can see a little bit of light and shadow, and then what I put in here is teleportation controls. So there are components for that, and you see a controller model for each of the controllers, and that's also customizable. I'm using actually laser controls here, so you have a raycaster coming out, and that way you can actually start interacting with these objects by pointing at them. I do visual appearance changes here just to illustrate that. And that was a first example. So ARJS, as I said, is then on top of A-frame, and really targets just marker-based. We are the webcam marker-based AR, okay? So let's look at it. What I do here is actually I bring back the same scene we just had. I just scale it down a little bit and I'll attach it to the marker. And so we're gonna learn more about marker-based and markerless AR in the specific lectures focused on those, but this is just to get an overview. And ARJS is based on JS AR Toolkit, and that is AR Toolkit. And that's why we see the hero marker there as one of the examples. We're also going to learn more about how to use custom markers and how to design markers for different kinds of marker-based toolkits. I would never underestimate marker-based AR. Don't think of it as outdated. It's actually very powerful for prototyping. Like, look at the flexibility that I have here. This could be a specific user interface element. If I want to figure out what's the right orientation or scale for it, I could quickly prototype this with markers and do an interesting form of immersive authoring using markers. It is one of my messages I want to convey through this course. So don't think of marker-based AR as dead. Think of it as a very powerful and useful tool, especially for quickly prototyping and developing things. So SteamVR, I said it's pretty popular. So it works with Unity, and you can reach a number of VR headsets, Oculus, Vive, and Windows Mixed Reality. What you'll notice, this is a little bit more complex example scene here. I'm going to jump around to a few different locations, and I'm going to try out some of the behaviors. A lot of these toolkits actually have example scenes where they show off the interactions. The support for interactions is really what we're after with the toolkit. Obviously, we want to have support to reach a wide variety of devices, but we also want to get off-the-shelf support for like controller-based interactions, bouncy behaviors here. Everybody needs a flower grenade, bam. And remote control. So I'm going to show you this. It's quite funny. I'm going to jump over there. Come on. Okay, here we go. Going to pick up this remote control. This brings together a few interactions in one. So now with my virtual reality controller, I hold a virtual other controller because that hand is my virtual reality controller. It's the SteamVR hand, the red one. And I can now play with this car. So it's driving around and it's quite cool. And now I really have to show you you can get me to use any toolkit as long as you give me a bow and an arrow, and I'm there, deal. So I do like SteamVR. I've used it in my class, at least in one of the years, and the students did a really good job actually. The documentation was fairly poor, I must say, and I'm going to miss that one. An example scene like this allows you to quickly learn and adopt if you have a little bit more time that you have spent with the tools like Unity and Unreal. Mixed Reality Toolkit. We are now entering augmented reality for a bit. So Mixed Reality Toolkit works pretty well with Unity, and then it works very well with HoloLens, and then it does have support for VR and also a little bit of smartphone-based AR. So actually relatively growing and broad support. It does also come, there's a Mixed Reality Toolkit version for Unreal. I don't know exactly how advanced it is and how it compares to the Unity one. I've actually only worked with the Unity one. So I like Mixed Reality Toolkit, especially when you get to play with it with a HoloLens 2. This is the hand interactions example here. It's just pretty cool. And the way this works is it's an example scene bringing together various behaviors, and actually what they do very nicely is they're putting all these different widgets next to each other, and so you can compare, play a little bit of the piano here, And so you can compare what these toolkits actually feel like and what their support is. And I think that is pretty cool. And you'll see more of this in other parts of this MOOC. And also when we talk about AR, we're going to have one lecture dedicated on moving from handheld to head-worn AR, and I'll show you a few more HoloLens examples there as well. Otherwise, I assume you have access to smartphone or otherwise marker-based AR. I think if you are becoming, or if you're already a Unity fan, Vuforia it might be a good choice for you. Marker-based AR via the webcam, and a little bit of support for AR Core and AR Kit, and also HoloLens, so that you can actually combine on the HoloLens marker-based AR with the HoloLens, and then you can switch over to extended tracking. It's a concept we learn about. Seamless switch from marker-based to marker-less AR. So I'm going to show you one of the examples with Vuforia. Here is the image targets example. So it actually would work, and I'll show you this at the end of this video. It would work with multiple image targets. You can actually get this to work. Each of these markers here, as represented by these images, have a 3D object associated to it. And the drone, so the second one, is the one that's even animated. And as I run it, I connect my webcam here. Let's run this, and I'm going to hold up a marker against the webcam, and when it becomes really visible, the lighting conditions are a little poor right now. I'm using a lot of light so that you can see me, but that doesn't work so well with marker tracking. And but it does look okay. This astronaut does fairly well on this marker. I'm going to try to get the drone to show up here. So the drone is animated. That looked a little dangerous, but the astronaut has just disappeared. So that's cool, and this drone is animated, as I said, and we don't have to just have it fixed there above the marker. It could actually fly around a little bit more. So AR Foundation, I want to cover that next, is a platform based on, and actually integrated, built into Unity. So it abstracts nicely from AR Core and AR Kit, and also has support for HoloLens. I'm going to show you one of their samples. It is actually the XR Interactions sample combined with AR Foundation. And then you can place objects and can move them when you tap them. After you tap them, you can then drag them and scale them. But you are limited to these planes, so I have to figure out a way to get to the lower plane. And here I can actually then reach the other plane. So that's pretty cool. XR Interaction is the latest addition to Unity, and it does work with both AR and VR. So since I just showed you an AR example, because it was XR Interaction combined with AR Foundation, I'm going to show you the VR example that they have in AR Foundation. So this is me teleporting, and teleportation is something we learn about when we learn more about virtual reality. It allows you to travel larger virtual spaces in a constrained physical space that you have or may have. And then here you can see a few of their what they call complex grab interactions. I really want to pick up this little, I don't know what it is, a llama, and yeah, it looks interesting. So that was the first overview, a round trip through some of these toolkits, so that we get a better understanding of the platforms and the toolkits and how do they work together. And this mapping will evolve. That is the current mental model. It's good to have this as a start and a starting point. And yeah, we're going to expand more on how to learn about and build our AR VR toolbox, and that's what I'm going to focus on in the next few slides. We're going to learn how to move and jump actually from 2D to 3D, so 3D objects and transforms, working with 3D models, 3D interactions. Okay, so that's the basics. That's our entrance into VR. This is actually not VR yet. So then we're going to design for VR. Okay, we have to think about the environment, right? We need to build a world, and then as we do that, we need to think about lights, shadows, animations, spatial sounds, so not just the visual. Keep that in mind. I would say then we enter the space of being a little bit more, well, immersive, but it's initial, so it's still basic VR interactions. So traveling, we're going to learn about object selection, so picking things, and gaze, gesture, and speech input. Now speech input, I don't do too much, but there is support. And advanced VR interactions, really we talk about menu design, a lot of placement, more like placement, because the actual menu design and the actual design patterns for menu design which we already need for selection, but then we're also going to talk about manipulation. So, so collision detection is one thing, and then obviously also you need to really apply transforms depending on how you move the controllers or your hands. We're going to learn about physics and particle systems along the way. I think all these things together would make you a little bit of an expert in VR. Just having at least this foundation, these are the things that you would be dealing with in VR. And we're going to have a case study. I'm really happy that we have this case study. It's about a zoo, a night safari experience. We'll learn about how to travel in there, how to visit different areas of this zoo. The zoo was modeled, but not done in collaboration. It was modeled after the Detroit Zoo. The Detroit Zoo has very high values when it comes to animal welfare. So we have a petting zoo and a feeding area, and that is something that is a no-no in the reality. But in virtual reality, we can do these things. And the cool thing about our case studies is they're done with me, but not by me. They're actually done by students who have worked with me, who have learned actually from my courses and doing independent studies and all kinds of things. So here we go, building your AR toolbox. That's the other thing that we're really gonna want to accomplish in this course. Okay, so we're gonna do this in the following. So we're gonna make a jump from VR to AR. So all the AR portions assume that you have done the VR portion. So don't skip ahead. Okay. We're going to cover types of AR displays. We're going to mostly do smartphones, so handheld, but then we're also going to talk about head-worn a little bit, but no exercises there, at least not for now. Registration, tracking, and calibration. We're going to talk about those things. They come through, but these are more like that the toolkit takes care of for you, so you don't actually have to concern yourself too much with it. And then we're going to learn about mapping physical to virtual objects. This is something, it's basically tracking, object recognition and tracking. So designing for AR, then we're going to learn about motion tracking, really how that works, environmental understanding, spatial mapping, and also semantic scene understanding. We're going to talk about that. Light estimation, we're going to talk about it a little bit. The support for light estimation is growing, so light estimation would allow you to render to estimate the light at the location where the virtual content is in relative to the physical world, and then adjust the lighting so that it blends in better. We're going to learn about marker-based AR, so we're going to learn about marker-based design, interactions, and then also going from marker-based to marker-less. And we're going to do more on marker-less AR, so marker-less design, a little bit more on the interactions there, although they can be fairly similar if you're using the right toolkits, and so you could even build one solution and then target both marker-based AR and markerless AR. And we're going to learn about going from handheld AR, so from the smartphone, to head-worn to the HoloLens. And as I just said, we can actually design an app like this one. This is our second case study. This is also done by a student of mine, Shweta Rajaram, and she's been really productive in her independent study. She did this in a little bit less than 5 weeks. She put this whole project together, and we're going to do a marker-less version of this. Takes a little bit away of the fun, I must say, but it's still a really cool solution. In fact, we built this one first. We built the marker-less AR version first. It's something we're going to talk about. What's the right order in which to explore these things? The goal of this project is to actually bring AR into the classroom, and we wanted to use meaningful examples from education, but it was still a technological exploration. It's pretty cool if you don't have to worry about the marker sometimes. But as we could see with the paper-based version, it can also be very powerful to actually have a marker printed on paper and then also make use of the paper. Well, I hope you enjoyed this little overview, and this is what it means to have a toolbox. And at the end of this course, my goal is for you to feel really comfortable having this overview of the space. So you should just be able to just talk about it like I just did here, and knowing which toolkit, what does it do, what's the support, which platform does it work on, what's the current support for WebXR, which browser does it not work there, do I need Firefox, does it work in Safari, which by the way at this stage doesn't. Apple. So thanks for joining me in this journey, and I hope this was a first good overview that was useful to you. In this lecture, we're going to learn more about 3D. In fact, we're going to make the jump from 2D to 3D. I assume you may have some experience developing web or mobile applications, but even if you don't, the 3D world is quite different, so it's quite challenging. And I want us to spend a little bit of time getting more familiar with how things work in 3D, how we should think about design and layout, and also how we should think about interactions. And this is really a foundation for what is to come in the following weeks when we build on top of this 3D programming and knowledge, so that we can actually then do things in virtual reality and in augmented reality, which are of course inherently 3D. If you think back to course 2, if you have taken this course, in course 2 I talked a lot about what it takes to create AR/VR experiences and prototyping, and I talk about really starting on paper and going through various levels of fidelity up to AR. And if you want to get from here to 3D, it is quite a jump, okay? So obviously along the way we could prototype using these other media, including 360, and I'll show examples of this throughout this lecture and also in other portions of the MOOC. But really what we want to focus on in this lecture is making this jump to 3D. So if you're familiar with how coordinate systems work, they start in the top left corner of the screen usually, so up there, but I'm just going to put this down here. And so this is the X, this is the Y. And so if you wanted to position a box like this here, let's say this is a div, an HTML div, and you want to do it in CSS, you set the left to this difference and the top to this difference in pixels or whatever unit you want. And in 3D, well, a 3D coordinate system, 0, 0, 0 is here. Now in AR, the 0, 0, 0 is depending on what kind of AR you're using. So if it's a marker-based AR, then it would be directly in the marker. The coordinate system is often relative to the marker. And if you are using marker-less AR, it's usually the location where you started. That's the world origins where you started the app usually. And but in just 3D, so this would be 0, 0, 0. And then if you wanted to put a box around the 0, 0, 0, this is how it would happen. It has a certain scale, same scale as this box actually. But a number of things just happened. I'm going to bring it back one more time. So first, just putting the object, adding light, and then it actually is shaded. And that is how things work in 3D. You actually do need ambient light. Without the light, you see nothing. And that is something to pay attention to. And then obviously now we have a 3D geometric shape here. We're going to learn about 2D versus 3D objects. So here you see various primitive shapes. So kind of like the 2D versions of the ones that I'm drawing over here, right? We have a cube here, a sphere here, and a cylinder. So the basic geometric shapes that we have. And then we need to learn a little bit about obviously layout. So we know how layout works probably in 2D. We have a position, X and Y coordinate. We have a size, so width and height. We do have a little bit of depth, but it's usually what just in at least in HTML and CSS, it's the Z index. So that determines which object is rendered in front of which other object. And we can use rotation as a transform to really rotate the object. Then when it comes to design, I'd say, we can obviously have lots of CSS properties down here. The important ones I would say are display, so whether something is visible and then it could be inline or block, and or not visible. We can control transparency, so using opacity, setting into 1 would make it fully visible, and then have background color and an image. So how does this work in 3D? Well, we have X, Y, and Z. So that means we have width, height, and depth. We can have a render order. That's something I wouldn't usually play with too much. We have a Z, and the Z really is what translates to the Z index the best. We have rotation. The x, y, and z can be in degrees or radians, but this is something we'll learn in a bit. And then on the material side, obviously we have visible, true, false. We can render things as a wireframe. So whether we want to actually really render a texture or just the wireframe is something we can control for. We can control for opacity, we can apply a color or a texture. And then one thing that is interesting, we can per default render the front. So this is would be rendered like this. If you render the back side, you can actually look into this inside this cube, even though when you're outside. If you do double, you can be outside the cube and you see it like this, front rendering, and then if you somehow clip into this cube, if you're going into this cube, it would render the back side. So that's something per default. For performance reasons, we usually choose front. I wanted to talk a little bit about transforms. This is a little bit of a cheat sheet here. It's something to keep in mind. So we've already established the 2D and the 3D coordinate system, okay? So we have X, Y, and Z here. So if we already talked about how to translate objects. Rotation right now, it's at 0 degrees rotation, and scale it's a little bit wider than it is high. If I wanted to rotate this, then I would do this with rotation. For example, 45 degrees would rotate this rectangle like that. And if I wanted to rotate this object, for example, around the y-axis, that would be rotating around the y-axis. We actually have, obviously, x, y, z around which we can rotate. And so that's something to learn, right? If you want to rotate around the x-axis, so this way, so this is a right-handed coordinate system in our example. So this is, the thumb is the x-axis, so rotating around the x would bring it to you, okay? So I'm going to show you this in a separate slide, but this is something we just have to spend some time on and get it into your heads. And rotation around the z is actually the same. I mean, if you do minus 45, it's the same as doing the rotation here. So it would rotate this way. And that's something to keep in mind and to learn. And this is this is the holy grail when it comes to coordinate systems. Left-handed coordinate system. So this hand, that's what we use in Unity. And the right-handed coordinate system, that's what we use in A-frame. And the biggest difference that you see is obviously whether the Z actually increases or decreases. That really makes the difference. So in A-frame, for example, when you move your head forward, you're actually decreasing the Z. And in Unity, it's the other way around. Confusing, but you'll figure it out. Let's talk about interactions. I think interactions are pretty cool and key to immersion. In VR and in AR they also work differently, and that's something, let's just establish the basics here for 3D, and before we do 3D, let's look at 2D. So clicking in 2D, obviously if you wanted to click this object, you would go there. That means you do mouse enter and mouse leave. So mouse enter, you click, which is mouse down, click, mouse up, bam, and then I actually get this event. So I get a mouse up event and I have that location. Actually, it's like kind of like in there. And this is an event. That's what it would look like in HTML and JavaScript. And here, so you have the cursor on this screen, and I'm using an illustration here from David Lyons, which I really like that illustration. And you're shooting from that cursor position a ray into the scene. Bam! And then you see which of these objects are intersected. And so you cast a ray from the mouse into the scene and return all the intersected elements. Those are the ones that you would be clicking in 3D. So for example, when you define a raycaster in A-frame, it usually wants you to say which objects it should be looking for, and then it will do the collision detection on those. And you can handle actually mouse up events, and they will be handled if you do in A-frame, if you set the ray origin to the mouse. So let me illustrate this to you using my own example here that I've implemented in A-frame. It's ray casting. So in this first version, you see a ray coming out from the right location, and as I adjust the orientation of that ray, I begin to hit other elements, and I change the visual appearance. I'll reduce the opacity of the elements that I'm hitting. So this is key. This is something that we actually learn more about in virtual reality. So here I'll show you, maybe it's starting to make more sense. This is the first person view. This is me with the VR controller pointing at these different virtual objects. And this is what it would look like if you were standing near me. And this is essentially the raycaster coming out of my virtual reality controller. And so we've learned about 2D, 3D objects, we've learned about transforms, we've just learned about interactions and raycasting. And finally, to actually see anything in the scene, we need a camera. So here's our camera. It's a perspective camera. This is the view frustum. And we have a near plane and a far plane, and these are clipping planes. So everything here would be clipped, and everything beyond the far plane would never be visible unless you move the camera and you're moving the near and the far plane, they're shifting it in front of you. So that means at some stage when you're hitting these objects, you would start to clip them. And before I show you an example of this, this is the field of view. Okay, keep that in mind, field of view. And obviously this, if you don't change your XYZ, you're just changing your zoom, then you're zooming into the scene. And zooming into the scene means actually having a smaller field of view, because you get to see less. You see things closer, but you see less at once. That's just how things are. So let me show you an example of this based on my little camera here that I have. I've actually set it up in a way so that you see a little bit of visual helper actually of that camera. I can jump into that camera. And this is the actual camera. This is like how when I'm looking at my A-frame scene, my Hello Web VR scene. These are my coordinates up there. And when I toggle, so I switch into this other scene, I can see from the outside what we're actually doing to the camera. So now we're going to adjust the field of view. Really, that actually impacts everything. It makes the dimensions of the near and far plane changes that. It doesn't change the actual near and far plane. So FOV, really, if you have a smaller FOV, that feels like a larger zoom factor. So this is an interesting relationship between zoom and FOV that you can see here. So for example, in the HoloLens 1, you have a 35-degree zoom. So it's like kind of like this. And in a virtual reality headset, you see more at once. This is 120 degrees roughly. So this was a little bit more than what it would look like on a VR headset. Now the near and far plane, these are pretty important. They are used for optimization and clipping. So basically we don't have to render what's outside the far plane. So we only render until then. And we only render what is behind the near plane. Nothing that is in front of the near plane from the camera will not be visible. So what I'm showing here is obviously adjusting the near plane. And when we're going to jump into the camera in a second, you will see how that actually clips the scene then. And here you can see how that actually then works for that scene. So when you're wearing a HoloLens, the default is to have it at 85 centimeters. So the clipping plane is actually quite far away. You can get it as low as 30 centimeters. So I'm now entering the second portion of this lecture, more or less. I want to talk more about 3D models and also a little bit more about materials and what it really takes to make things appear in 3D and then later in VR and AR. Scale is pretty important. You will see this throughout. It comes back to us. It haunts us. The scale of 3D models and pivot points and all those kinds of things to control their orientation, and that's just something that always causes issues for my students. So hopefully we can prevent those if I tell you about those issues early. So here we go, 3D primitives. So here's an example that is just the standard A-frame scene. You see a box, a sphere, and a cylinder. And what we can do, as we're entering a little bit more 3D modeling, one way to do 3D modeling is constructive solid geometry. And obviously you can still see the sphere here, but I'm using this sphere to cut out a spherical shape out of the box and the cylinder. And if you do this a lot of times in different interesting ways, you can actually do 3D modeling. So I think as an AR/VR developer, it would be great if you had the skills of a 3D artist. But I think a lot of us don't, and we actually we need to understand though how 3D models work. So 3D models consist of geometry, mesh, and skin. So this would include the vertex positions, the normals, so the orientation, the faces, the texture coordinates. So this is, let's say, the layout, okay? And then the design, let's say that's the material, okay? You have a shader that renders it and can apply different effects. Can also be used for post-processing. There's a lot of cool stuff going on there. And then we have bump, normal, and other kinds of maps or environmental maps. These can be applied to the 3D models in order to not have too many additional vertices and still give it a detail. It's a simulation of detail, like a bump map. So textures are the other thing, right? So these are the image sprites that are attached or like wrapped around the 3D models. And then you can find 3D models online that are rigged, so they have a skeleton inside and they are animated. So for that, the rig consists of bones and then the animations of poses and keyframes. Most of the time you will have to deal with different kinds of 3D file formats when you're working with 3D models. So GLTF is really the common, kind of like a standard format on the web. So keep that in mind. When you work with Unity, however, it's FBX. And then we have Collada, or Digital Asset Exchange, DAE, as a still popular file format. You will see export to Collada or DAE quite a bit. And then OBJ and MTL material is kind of very early on file format, still popular, kind of like most tools will be able to export to OBJ, but then the material needs to be exported separately as an MTL. And then the textures come usually in JPEGs or PNG, so you actually then have like 3 kinds of things you have to keep track of. GLTFs can be packaged into GLB files. That's something that I often do for my A-frame examples. It's pretty cool. So I'm already bringing it here into an A-frame scene. So we have the bunny in there, and if you're using a perspective camera, the one that I introduced earlier to you, we can rotate, we can use look controls and rotate, and we're getting this camera for free in A-frame. So if we wanted to bring in multiple 3D models, here is an example. We have the bunny still there. This is a hamster. I didn't create this hamster. This hamster actually I found on Sketchfab, and it's been a regular visitor to my lectures. Rada Lapina created this and shared it as public domain. Finding and creating 3D models, I would say, should always try to find 3D models, unless you are a 3D artist and you are good with modeling. So places to find 3D models include Sketchfab, Google Poly, SketchUp's 3D Warehouse, Clara.io, and Adobe Mixamo. That's where Elvis is from. I'm going to show you Adobe Mixamo and Sketchfab. And programs to create 3D models, which are out of scope for this course, are Blender, Tinkercad, Maya, 3ds Max, Cinema 4D, and lots of other ones. Here I'm going to show you the hamster. This is a little video on understanding 3D models. So we're going to zoom into this hamster. And so it comes with animations. Actually, what we're looking at right now is a Sketchfab model. So it's hosted on the Sketchfab platform. It can be downloaded in different ways. And it was created by Rada Lapina. So at least that is the name that's up there. It's obviously available under Creative Commons. So let's look at how this hamster is actually done internally. So first I'm showing you the rig. It's pretty interesting. So these are the bones in there to get this guy to walk and animate. And here I'm showing the hamster as it is embedded, so exported from Sketchfab and then uploaded and hosted and embedded in an A-frame scene. I call this the hamster. And I gave it a little bit, I put it on a path and I let it walk around a little bit. And here I show an example of Adobe Mixamo, an example for animating 3D models. And here I have Big Vegas. And I'm looking for the animation that lets him fly. I want him to fly across the city. I want to turn him into a little bit of a Superman. But before that, I'm going to show you, obviously, lots of really important other animations are available to us. Dancing, different kinds of dancing. And so Mixamo is really a tool that allows you to apply different kinds of animations to an available set of characters. And so you can preview some of these animations and then you can actually adjust and control various parameters for each of these. So this is him jumping down. And here it is, finally, we have him flying. I was really looking for this one. And it is fun, it is super cool. And I like some of the parameters you have. You can change his awareness, so he really looks more around. So Mixamo is a tool I would invite you to play with. And I've seen some of my students create really cool scenes this way. If your main goal is to, all you want to do is just view 3D models, then I can point you to Model Viewer. You don't have to go through all the effort of doing A-Frame or Unity or whatnot. So Model Viewer is a pretty customizable JavaScript library and lots of things you can do and configure. But the example that I wanted to focus on is the one with WebXR. So the model viewer can actually be run on a phone, as I show here, and they have a WebXR demo, and I think that's a pretty cool one. So you can preview different furniture. It's based on a Shopify example contributed to model viewer, and you can bring in a chair like this into the 3D space, do a little bit of the initial tracking by moving a phone around, letting the phone read the geometry of the room, do plane detection, and there we go. We have it in the room, and you can customize it a little bit, at least change the scale of the objects and bring in different kinds of objects like this model train. So that was a lot of 3D stuff. I said making the jump from 2D to 3D, and I showed along the way was actually 360. I think 360 can be very powerful, especially for prototyping 3D scenes, and then especially for VR. I think it's a very good way to do things. So I wanted to show you a little bit. I wanted to explore a little bit with you how to go from 360 to 3D. So if you have a 360 camera like the one that I'm using here, then you can take a picture, a photo of a 360 photo to be precise of my lab, for example. This one is the one that Max took, and then it can be, this is an equirectangular format, so you can see some of these distortions, but then it's kind of like has two fisheye lenses, the camera, so one fisheye lens, the other fisheye lens, and then stitched on the side, can be stitched together, so you can actually wrap it around the sphere, render it from the inside of that sphere, and then, so the back side, if you will, and that would then give you this little planet view. Here's an example of that photo, this 360 photo in a frame. So now we can actually look around. Hey Max, how's it going? And could then also go into VR using that button in the right browser. And here is a version of my lab that is actually based on a 3D model. And so I'm going to open this as well in the browser in A-Frame, and now we can look around, and well, it doesn't look exactly the same. Obviously this is a simpler 3D model, but we can walk around and we can adjust our perspective. That's something that you cannot do in a 360 photo without very weird distortions. So this is how you would enter my lab, and then I have a number of screens on the walls and lots of equipment in here that we haven't modeled. And so this is the 3D version of the lab. Now I wanted us to compare 3D and 360. Okay, so characteristics of 3D are on the left. So 3D objects have width, height, and depth. That's very important. 3D objects are positioned along X, Y, and Z axis. And 3D objects react to light, cast shadows, and actually can be interactive. Now 360 is not 3D. Okay, it's actually represented in 2D. There's a projection function that projects it from an equirectangular to spherical format, and then if we map that then onto a sphere, then it gives you this illusion of depth, but there is no depth. So 360 has no depth, meaning you can't really walk inside, and 360 photos and videos are quite immersive, I would say, and can be interactive. You can do that by bringing in some kind of like image maps, if you will, for 360, so defining areas in there that are clickable. A lot of tools do that. Like Google Tour Creator is one of those that where you can do these kinds of things. So 360 isn't really a focus of this course, but I wanted to show you a comparison here. It's going to just jump right in there, and here is a 360 photo in the background, and I have the lab modeled on top, at least to some extent. It's really hard to get these perspectives to really map, so screen to screen, window to window, couldn't do that. But what I can show you is when I walk inside that 360 sphere, I'm turning it into this tiny planet view, and that's because we don't have depth. But inside this room, I can really comfortably walk to the window, to that window, and because we have a perspective camera, it actually adjusts the perspective nicely. So thanks, Max, for helping us give this little demo showing the differences between 360 and 3D. So let's go back to the slides, and this is actually where I wanted us to be, so right on time, and a bit longer than some of the other lectures, but quite fundamental. So what you should keep in mind is that 2D layout and 3D geometry, that's the terms that we should use. So when it comes to transforms, that's the term we use to control position, rotation, and scale of objects in both 2D and 3D. And left versus right-handed coordinate systems, I talked about this. I think we need a little bit more time to really notice and fully realize the differences. That's cool. 2D design versus 3D material, right? So language-wise, materials are enhancements of texture mapping. So really, actually a lot more to learn about materials. I didn't go very deep here. If you're really into creating really nice virtual reality scenes, there's so much more to be learned about, for example, physically based rendering. And 3D models versus 360 photos, who wins? Well, the 3D models when it comes to depth and detail, but 360 photos can help you really quickly prototype. You don't have to be a 3D artist, lots of ways to get 3D models. I covered a few platforms that you can download from, Sketchfab, for example, and Adobe Mixamo. 360 photos are really great placeholders for 3D models of the environment. And so before you start modeling the lab like we did, I would just do a 360 photo, and you could see how quickly this allows you to approximate roughly the 3D space that you have available. But again, 360 photos are essentially 2D representations, and they don't actually have depth. So I hope this was a useful lecture. I hope we made this jump from 2D to 3D together, and you're starting to feel a bit more confident. Join the honors track and play around with some of the exercises I have for you there, where you're building a 3D scene based on whatever you feel like. You can recreate your favorite movie scene or book scene that you had in mind in your imagination, and you can actually play a bit around with 3D in WebXR or Unity, so in A-Frame or Unity or Unreal even. And I think this would be a great starting point so that we can then learn more about VR and then AR in the following weeks. So I hope this set us up and set us on a good path to exploring more about these interesting worlds, AR and VR. In this video, I'm going to provide an overview of A-Frame as the tool of choice to develop WebXR scenes. I've already established what WebXR is, and I've talked about A-Frame previously, but in the XR development oriented lecture. But in this video, I really want to show you how you can use A-Frame to create VR and AR scenes, how to run them out of the browser on a desktop in a VR headset like the Rift S here that I'm going to use, or actually deploy it to your phone. And I'm going to use an AR Core smartphone. So A-Frame is based on Three.js and WebGL. And so Three.js is a popular graphics library. It's actually a WebGL library on top of the web. I've talked about this before. And so it allows A-Frame to render 3D scenes. And so what A-Frame now does, it actually introduces new HTML tags for 3D scenes. They all start with an a scene, a box, a sphere, a cylinder, or a camera, or a entity. It comes with an inspector. I'm going to quickly talk about the inspector. You should not forget about the inspector. It's not like an editor really like an Unity or an Unreal, but it's an inspector, and it makes things a little easier. And you can use it to explore different kinds of scene compositions and then copy-paste the values into your code. So that would be a way to go about it. A-Frame has asset management, so it supports images, videos, audio, and 3D models. Since it's web-based, GLTF 3D models is the preferred format. It does support OBJ and MTL, but that's a little outdated. And other formats like FBX could be loaded with A-Frame extras. Comes with loaders. So Three.js actually implements a variety of loaders, and they can be exposed to A-Frame, and that's what the A-Frame extras, for example, does. So it's a library on top. Then it follows the ECS architecture, Entity Component System architecture, so has many open source components. I'm going to give you a little bit of an overview when we're talking about VR and also AR. I'm going to introduce you to lots of little building blocks, because I do think that if you choose the WebXR route, which I think is very cool, you're going to need more help finding these things. So I put all these things together. If you choose Unity or Unreal, there are lots of good resources out there. It's very professional. And you won't need as much help when it comes to finding things. So I'll focus my efforts on providing you help with the WebXR approach. It's also the approach that I really like. It's a cross-platform XR approach. Good, so here's the Hello World scene in A-Frame. It's a Hello Web VR, I think they used to call it. I just call it Hello World in A-Frame. And here is what that scene looks like. So it's an A scene, box, sphere, cylinder, and plane. Here's the inspector that I mentioned, which I think is very, very useful. It's not super powerful, but it's useful. So you can bring it up when you press in an A-Frame scene, when you press Control-Alt-I, and I do this from time to time in my instructions. And it has like these transform controls from Three.js, so you can actually obviously move things around, translate, so you can also rotate and scale. And then you can manage components, and most of the editing you will do in an editor like on CodePen or Glitch, I suspect. We're also going to talk about those kinds of environments for setup. So these things cannot be stored directly. It's an inspector, just like a web developer tools in Chrome or Firefox there are also inspectors. You can export, you can save, there's a save up there, or copy paste to clipboard. Those things are possible, but well, I think it takes a little bit of time to develop your workflow. But you have a lot of similar features to a smaller subset, but those features are similar to the Unity and Unreal editor. So I was talking about A-Frame development environments. So one thing we should consider is how are you going to work on these things? And you see me use a combination of Glitch or CodePen or GitHub. So I would say Glitch is really like you're going there, you can launch an editor, it's going to load. In this case, I've actually just like linked the A-Frame example, and I'm going to do this in a bit, but you can just like show it next to the code, and this is the scene and this is the text, and you can then remix and take it from there. So that's pretty cool. Now CodePen is very similar. I mean, in many ways I would say there is a difference. So an important difference is with Glitch you're actually really hosting things in a, well, it's running its own Node.js server on virtually. The projects I have in mind for us are not going to be that difficult. The most difficult part is how do you host assets? Like what do you do there? Because these platforms have a little bit of restrictions, but you can actually do a little bit of asset management there. So I'll show you CodePen very quickly. So CodePen here, this is my A-Frame template in CodePen. I'm pretty active. I'm a pro, it says. Just means I pay for this, so I can help my students. And so this is the A-frame template we just saw before. It's the code on the left. That's a little bit of documentation. I usually have that. I actually have lots of examples on CodePen. So the profile here has my cute little winter scene. I don't think it works anymore. A-frame has updated recently, so it looks good in this screenshot, but if you open it, it's probably going to be sad. I'm going to show you the Star Trek one. It's one of the early ones that I've created. The hamster, I'm going to show you that a little bit. Let's look, for example, at the Star Trek scene. So CodePen is like similar to Glitch, also has like an editor. The focus here, I mean, you can change the view and all that. I leave this up to you to figure these things out. You can do different layouts, move these things around, and you can set up whether it should always update or not when you're typing here. It's a lot of things to play with, but I suspect you will have some fun coding here. And GitHub, if you're a little pro, sure, why not? But then I can't help you. I mean, I could, but it's a little bit out of scope for this lecture. So GitHub, I just say custom, okay? So I wanted to talk about A-frame and VR. So A-frame development would be in one of those tools. So I usually use CodePen or Glitch. It's directly hosted, allows me to go on a different device, computer, whatever. So would also work with AR. You just go type in the URLs. Glitch is even a little better. For CodePen, you need to view the debug page in the browser. So that's something to keep in mind. And then you're running it in a browser, so a WebXR compatible browser, for example, on the desktop. So I will use Firefox in my example in the following. And then you're using a VR device. So I'm going to use the Oculus Rift S that I have here next to me. So I'm going to jump in there, and I'm going to spend like 10 minutes really going over all the basics. I'm going to use Glitch, and my goal is to really get into VR. So let's get started. So I'll start here with the A-frame website, and we're going to look at the Hello Web VR example. It is a scene that we will see a lot. It's the standard A-frame scene, and so well, it does seem a little different from normal web content. Now the whole thing seems to be draggable, and that's correct, because what we can actually do here is we can drag the camera. So this is controlled. This is look controls, and these look controls allow us to take a different perspective on the scene. We're actually rendering the perspective from a perspective camera, something I'll talk about in later segments as well. And the other thing we can do is fly around in the scene. I say fly around, and actually it's more like walking around in this case. Flying is not enabled, but we can use W, S to go forward and backward. So we can use W, A, S, D to actually navigate around. And we combine it with the mouse, we can actually fly around, or walk around as I said, and take a look at the scene. There's nothing else in the scene. It's really just these basic 3D objects, you might think, but there's something that is obviously quite fundamental to this scene, and that is the light. So we do have shadow here, and so let's inspect this scene a little bit with the visual inspector. You can do this right on this A-frame IO website, so you can go into the visual inspector, or you can press Control-Alt-I, at least on Windows computers. And so I can now use my mouse wheel and drag with the right mouse, and then drag with the left mouse. That changes rotation. Drag with the right mouse. That changes basically the position of the camera. And the mouse wheel gives me control over the Z-axis of the camera. Now this camera though is actually not the camera of the scene. The camera of the scene is here. So we can actually draw that in, and so we can see this is the camera of the scene. One thing I'm going to do is, this is an inspector, but it's also a little bit of an editor. So I'm going to change the background color here to black so we can inspect this scene a little bit better. Okay. So as I said, here's the camera, and you can see how it's looking at the scene. And we can actually change the position of the camera. We could go further back and a little higher, and maybe a little bit to the left. So I'm now changing the coordinates here through the gizmos that we have, But we can also do this over here. So I can drag left or right as I start. I need to start clicking while I'm in the field. So I'm going to do it for Y, up, down, up, down. So you can practice this a little bit. And then Z is never really clear how to move the mouse. It's always inverse of what you would believe should happen. So smaller coordinates means actually further into the scene, so further away from the camera, you might say. And we were just moving the camera, so in this case, that's just how it is. All right, we can also change a little bit the rotation. Now, rotation doesn't actually have an effect when you look at the scene, because we have look controls enabled on this camera, so we would need to disable it in order to be able to do what I had in mind. So now if you go back into the scene, you see you get a slightly different angle onto the camera, and so I'm going to rotate again a little bit differently, and so now we would be looking more to the left, and I'm going to look a little down as well. So now if we're going back to the scene, we would look down. And so, but we want the user to have control over the camera, so we can just ignore the rotation. We can just set it back to 0, 0, 0 the way it was. And the camera is usually at 0, 1.6, and 0 is a normal camera position. This is where you are initially. 1.6 on the y-axis is used, it's the standard height of a user, 1.6 meters. So that's just like how it is. So I said there is oops. I wish there were an easy way to undo, but we just like set rotation back to 0. I didn't want that. So now we're going to actually go into lights. So one thing you'll notice here is that there is a light that I have opened. It is actually an ambient light. We can show you the type. So ambient light really doesn't do much other than like giving this scene a little bit of a light, and it's independent where that position of the light is. It doesn't matter, but the intensity matters. So we can change the intensity. You can see how the scene brightens up a little bit there. I can go a little bit inside here, and or down, and then it's pretty dark. There is still an additional light, which is why you can actually see something even at 0 intensity, and that additional light is a directional light. So now that is the light that is responsible for casting the shadows, and you can see this as I'm adjusting the light position a little bit. Now I'm dragging the camera rather than the light, so let me drag this position a little bit. You can see how it changes, how it casts the shadow differently. So that's all pretty cool. And so that's a quick overview of A-frame, and we just changed it. So I'm kind of using the Chrome browser, and in Chrome we don't actually have support for VR yet. So that VR button is just going to give us a full screen view. So if you don't actually have it running correctly later in exercises, if it doesn't go into VR, then obviously either your VR headset is not connected properly or you're not using Firefox. So I'm going to quit this one. I'm going to go into Firefox. I have Firefox here as well. So I'm going to go into Firefox. And this is the original scene. So this is the same scene in Firefox. And now here in Firefox, what I'm going to do is, so we're going to go into the screen here. I'm going to press VR. And now as I put down my headset, it is beautiful. You can see a render for each eye. And I was just checking what you're seeing. It's pretty cool. Now this scene doesn't actually support controllers yet. We'll add support for all that later. But it is cool. We are in a web browser. We are actually looking at web content. And then when that web content actually embeds VR content, we can seamlessly switch to it. Now that is pretty cool. And it's puts us into a unique position where we can actually mix traditional 2D web design and web development with advanced, I would say, AR/VR content creation. So that was me giving a little bit of an overview of A-Frame and the VR portions of it, and using the Rift S that I have here. So that's VR, okay? And now we're gonna do AR. So what does it look like for AR? So I'm going to show you here. We have A-Frame development environment as before, and then you're switching actually to mobile. So you cannot use it on the same desktop, same browser. You actually have to run it in AR. Unless you're doing a marker-based AR, then you can actually run it with a webcam on a desktop. I'm going to just jump right into the demo, and I'll see you afterwards with a few concluding remarks. And so what I've done now is I'm actually like in Firefox. So I have both the source and the scene there. And so I'm gonna change this to, we're gonna start making some changes here to 0. So this is now black, right? So if we're gonna get this notification here every time, so I'm just going to accept, yes, we can run this in VR, and I'm going to accept it for this site. And so then, so this kind of like editing and switching back and forth is maybe not ideal. So let's say we're going to do a series of smaller edits. So what I'm going to do is actually I'm going to have this next to my code here, and we're going to hide this on the left. So now we have a little bit more space. And so we're going to do not too many changes, I would say. We're going to give it a little bit more of a different color. I like sky blue. Sky blue is a nice color. And now what we're going to do is we're going to change a little bit the position. So we have X, Y, and Z here. So we're going to go down a little bit on the Y. So we're going to create a little bit of a distance here between the objects, okay? And then we're going to move out that cube a little bit. So moving out that cube means we're decreasing the X even more. So let's say to minus 1.5, so now it moves out a little bit more. And the cylinder, we're going to move a little bit more to the right, so the yellow cylinder, so we're just going to 1.5. So now it looks like we are splitting a little bit the scene, and therefore what we're going to do is on the sphere, we're going to do both a little bit up, so just 2.5, 0.25 up. That didn't change too much. Let's do 175, so it's definitely a little bit more visible. Not too much still. So let's just go a whole point up, okay? And we're also going to go a little bit more backwards. So it looked like we are spreading out these elements a little bit. Obviously, the perceptual differences in terms of when you change depth, not so high unless you really make a significant change. Now it's really far away. Okay, so I didn't want that. I'm just going to bring it back, and you see the updates here on the right the whole time. Here we're going to basically just press our VR button. I'm now looking at the scene, and it's quite cool. It looks like, wow, it has changed quite a bit. Now the shadow from the sphere is more or less gone. So that's just because the plane isn't long enough. And we can inspect why that is a little bit. So I'm going to quickly reload so that actually escape here, not reload. Reloading is actually hot. Now that is the cool thing. Let me show you this. While I am in VR, so I'm going to quickly jump back into the headset. So if we now make changes, let's say we're still trying to find the right color for the background. I'm just going to make this a different blue. I can see this right in the headset. And so that's just really powerful. The last thing I wanted to show is what this would look like in AR now. So for AR, we can leave the background. Let's say we're going to give it a green, and I'm going to escape here. So what do I mean by this green? So this, all you see in this green is like our green screen now. And this will actually be replaced by the camera feed. If I now press this in new window, I get this domain, URL here. So, and there is our scene
in AR. So here we're going to explore it a little bit more. And now it seems weird, right? It's like, why is this not reacting like it should? You're going closer, and it seems so weird. It seems to be floating. And this has to do with the simple fact that our dimensions are really, really big. So that we're talking about these objects being 5 meters away, and that's really breaks the illusion. So one way to do this would be we change all the positions here and then the scale and all that. But what I'm actually going to do is we're going to grab this into an entity. This whole thing is going to be into a different entity, and I'm just going to show you quickly how this works. And then we're just going to scale this down to really like small. Okay, now that's now baby size-ish. So it's 1/4 of the dimensions, so that means because some things are up to 5 meters away, 1/4 of that is actually then still a meter away, and well, we're going to make it even smaller then. Let's do 15%. So every distance, every size is now 15%, which also means it's actually more like on the floor. So we're going to bring that entity up to, let's say, a comfortable height, so 1.2 meters floating in front of us. It reloads. It didn't change too much in this 360 view, but now when we go into AR, things should appear a little bit smaller, and now it feels like, oh, this is so cool. We can explore it, we can get closer to it. These objects still appear pretty big, but that's because they are now so much closer. There were a little bit of tracking issues for a sec, but it does look pretty cool. And now we're looking at our A-frame scene, basically live. Alright, so this was our little A-frame demo. We've covered a lot of ground, and we're going to explore A-frame quite a bit throughout this MOOC. I think it's quite an accessible way for us, and it's easier for us to learn about AR, VR if we already have a little bit of web design, web development background. I'm also going to cover Unity and Unreal, and so we're going to learn quite a bit on actually doing AR, VR, and in this case, development. So really, what some people might call programming. Okay, so don't be scared. It'll be fine. We'll figure it out. In this video, I'm going to give an overview of the first steps in Unity. My focus is, however, not so much on like, here's Unity and this is all the things you can do in Unity. No, I'm going to quickly jump into more or less using Unity to create a 3D scene and then actually run it in VR, which just means like getting the Oculus Rift. Where is it? So the Oculus Rift on my head and adding the XR plugin to Unity. So I'm going to show you that, and then we are going to do both markerless and marker based. So both marker based and markerless AR. So I'm going to show you all this, and I suspect that just like with my first steps in WebXR, this video should be a reference point for you. So obviously I'll show you all the things before we have really talked about VR and AR. So in the next few weeks we will actually then dedicate our efforts to a VR scene and then to an AR scene, and I think this video might be helpful for you. So I'm going to give you these demos, and so let's get started. So I'm going to show a few things here in Unity. So this is our camera, this is our light. It's a relatively empty scene for now. Up there is the sun, okay, so we can see that from the directional light, which is this way, so the sun would be up there. So we're gonna insert one plane for now, and that we're gonna put that at 0, 0, 0, so that's the origin. And now we have a little bit of a playground to play with, but no objects yet. And so in our first steps in Unity, or your first 3D scene in Unity, the idea is to model it after something to challenge you a little bit. And so my example is going to be when I came to Michigan, then yeah, I saw the bell tower, the Burton Memorial Tower. So I'm going to just grab that image and I'm going to save it here on my hard drive, and then I'm going to get it into Unity. We can just import a new asset. So we have a tower here. And then, so it helps to have a reference, I thought. So the idea is we're going to place that tower here now on that kind of plane, create a duplicate of that plane. So we're going to call this a reference, and we're going to add that to it. So this is my reference picture. I'm going to rotate it down so I can see it a little bit better. Okay. So this is my reference picture, and now following this reference, well, there's not too much we have to do. I'm going to give it a bit more space here so I can actually have more to play with. Well, all we need, if we make it very simple, is a 3D object, and that's our tower. So Burton Memorial Tower, okay. And we're going to put that reference image up there. And so we had the plane, we have the tower, if you will. It is currently at a very weird, we're going to center it, and we're going to actually raise it out. So, and then we're going to make it a bit larger. I'm going to stretch it first, so that's one way to do it, but I'm actually going to make the whole thing a little bit larger. And then the other way you could scale along Y would be to drag it here, and we're going to make it larger. And yeah, so you make it roughly, needs to be a bit bigger and also fatter. Now it could be that this thing is actually kind of squarish, okay, and we're going to enter just like clean values. And so it is 7, so we're going to put it at 3, 5, then it's like standing right on the floor. So, and that is our tower. And now the light is, I said, the light is now behind us, so the light is in here. So we're going to play a little bit now with the sun. So the light is up there, the sun is up there. Going to zoom out a little bit so we can play with this, and for that we're going to use the rotation tool, and we're going to have, actually we're going to move the camera a little bit backwards, so -15, and we're going to look at the camera again, zoom onto the camera, going to play with the camera a little bit more. Now the problem with that view is that it's right where the light is, so we will not actually see a lot of cool shadow stuff. So I'm gonna actually go to this side, change my mind. We're gonna grab the camera again using the translation tool. We're gonna move it to the left, and now we have to rotate it. I'm gonna use a few shortcuts here. So rotate it this way, and also have it a little bit like that. And we are too close now, so we're actually going to zoom, we're going to go backwards a little bit. So alright, so now it's pretty cool. Okay, so this is a game view now, and so we have our beautiful tower there, the Burton Memorial Tower. We have the plane, okay, there's a tree and there's another building connected to it, which we're not going to do now. I'm going to like disable the reference image for now. And actually, so keep in mind that if you do it here, it's just hidden actually in the editor. So what we should actually do is actually disable it completely. So now it's gone from both the game view and the editor. So that's something to keep in mind. And now what we're going to do is we're going to play a little bit with the light. So I'm just going to grab that light. So that's where our sun is, okay? And I'm going to rotate and simulate a sunrise. Okay, so here's now Now I'm going to do it the other way around. I'm going to actually rise it, and here we go. And it's pretty cool. The other thing we can do is obviously we can move the light this way. So depending really how it moves along the horizon. This is not really realistic, but now what you get is the sense of our first 3D scene. We have light in here, we have a camera, and we have a little basic building, and it's modeled after our reference image. So, and we're going to look at it from the other perspective. Also keep that in mind. And now we created our little example scene. And I went over camera placement and playing around with the camera, with the light, and then brought in a few basic 3D objects. Now, if you press play, nothing special happens. It's just like playing the scene. I've activated maximize on play. So now what I'm going to do is actually adjust it a little bit further for VR. What I didn't like is the size. And I also didn't like so much where the camera actually is. And so I'm going to do both. And I'm just going to adjust a few things here to get it ready. And I'm going to focus my efforts on actually increasing the scale of the building. And I'm still trying to keep the proportions. Like I'm using the image here as an orientation. It's kind of like in the exercise, in the honors tracks, I would like you to use a sketch as a reference. Here I'm using a photo. But that's okay. And so I put it there, and now looking at my XR rig, I'm thinking, okay, that's not bad, but it could also be interesting to actually just like stand down there, like in front of it, and that's the experience that I have, right? When I see the Burton Memorial Tower, when I go to work. So that's what I'm trying to recreate here in this experience, and that's why I wanted to make the building so much taller. And I'm just like figuring out the right coordinates, and we kind of like have my little preview in the main camera down there, and I think this is not too bad. It's I would say it still looks like I'm far away. It's not that experience that I have in mind. I would like to be kind of like a little closer. I do like seeing the sun. The scene is admittedly a little empty here. I'm just focusing on this one primitive, and this may happen to you as well when you work on the honors exercises. I'm going to ask you to do a few things, but I mean, just getting some of the things with these primitives right, that's just like, okay, I'm going to go all in here. Okay, so that was Unity, doing a 3D scene in Unity. Let's make this transition from VR to AR. So in terms of toolkits. So I have shown you XR plugin. You could, as I said, add XR interaction toolkit directly in Unity and then also have more support for interactions. You could go alternative routes. I talked about that. So now if we look at AR, we're going to, interestingly, keep this the same, right? It's the XR plugin. You just configure it slightly differently, and you're going to do XR interaction toolkit if you want to. What I would really recommend is doing AR Foundation. So AR Foundation in combination with XR Interaction is pretty cool. I'll just show you AR Foundation. That's all I want to accomplish now. And we also can do the same thing in Vuforia. So that is marker based, that is marker-less, keep that in mind. There are alternatives. You could directly build on AR Core, AR Kit if you want to. If you happen to have a Magic Leap, I was running out of AR headset ideas here or AR devices ideas here. So I don't actually really, I've never really developed for the Magic Leap, so I don't really understand how it works. I do think there is support for that in Unity. And AR Core and AR Kit, I would just go via AR Foundation. I mean, it used to be, in one of my classes a few years ago, we developed directly for the AR Kit and AR Core plugins that were hosted in very interesting ways. There was no AR Foundation yet. Now I would just go AR Foundation. Unless you really need the latest features in AR Core and AR Kit, I can understand for your like future projects, but in our case, for our honors track in particular, I think just go AR Foundation or Vuforia.
So I'm going to do one version of that scene that I just created for VR. We're going to do one version with marker-based AR in Vuforia. So all I want to accomplish is get the building to appear on the marker. It's going to take a bit, but and then AR foundation, so markerless AR. And what you'll notice there, as I'll show you in my demo, I had to adjust the scale again. So keep in mind that a unit of 5 meters is 5 meters away, and it just won't feel like it's right in front of you. And so that's something to pay attention to. So I'll show you these two demos. Alright, here I have loaded the scene from before. It was a scene that was optimized for VR. We played around with where to place the rig and whether we want to stand in front of that tower or where we want to be. I had different versions of this, so further away or like being really on the floor, standing right in front of it. What I'm going to do now is I'm actually going to save this as a separate scene. We're going to do on the scenes, we're going to do a final scene Vuforia. Okay, we're going to do a marker-based AR version of this. So this is now our final scene Vuforia. The first thing I'm going to do is actually delete the XR rig. Okay, so then we're going to get we have Vuforia here, and the way I got Vuforia was through the package manager, but this always differs in Unity versions. But anyway, I've already imported it into my project, but I had it in my assets. And so we're going to get the AR camera. So the AR camera is kind of like our XR rig, but it works a little bit differently. So when I start this now, all it does is it shows that cube and everything. It doesn't react to the marker yet, but it gives me a webcam and all that. So what we're going to do now is we're going to place the cube on this astronaut here. This is one of the Vuforia standard markers. So the way I'm going to do this is I'm going to get the image. So we have an image target here. We are going to use their database, so Vuforia images and the astronaut. I like the astronaut. Okay, it's cool. So the astronaut is there. And if I now hide the tower for a second and the plane, then what you can see is that this marker is like tiny, okay? And the VR stuff is super big. So what we're going to have to do is actually adjust the scale. So I'm going to actually fly a little bit up here. And since we have much smaller scale now, I'm going to change the camera speed to like half. Anyway, so that's like our target in the end. And so if we have a monster tower that I can't even see right now because like I'm inside. So what's the thing? We're going to actually reduce this massively in terms of scale. I'm just going to work with values here, so I'm going to make this a 0.11 scale, so pretty tiny. I'm going to show you the plane first. So that plane, I would like to have a little bit of a plane above the marker, and that is still like quite a big plane, right? So we're going to make this even smaller than. So you size everything relative to this marker now. Okay, and we're going to bring it up a little bit because we don't want to have this kind of like flicker issue. I'm going to actually do it like this. So then we're going to get our tower. Bam, tower, pretty big. This one we really have to get down as well. Let's try this. Also, we're actually going to place this inside the marker. So we want this to render when the marker is detected. Okay, now you can see the tower is pretty big. Now that seems really a bit tiny. Anyway, so we're going to have the plane here. I'm going to make that a little smaller still. I'm still not so happy. So like this, maybe. Yeah, okay. And then this one should stand on top. So at 0.75 is when it's exactly on top of our marker. We have the marker. Okay, so much fine-tuning, and I'm going to run it now, and I am going to be very happy if it works. There is the reference image is still floating, but here is our tower, so that's pretty cool. And I'm also going to get the reference image in there. So reference image, I'm going to place it in there. So here is our scene, pretty cool.
obviously it is modeled with primitives, but what we are really interested in right now is in getting a better sense of AR and VR and how to transform and transition between these two. So that was using Vuforia markers, the astronaut. I mean, I could actually adjust that, could create my own marker, can figure it out, go to the Vuforia website if you really care. I didn't, I just wanted to have it visible in AR to show it for you. Then just we need to use markerless AR, okay? So now I need to actually deploy it to the phone. So that's going to require to connect it via USB and setting all this up. And I'm going to spare the details, but it will require some time and effort to actually get Unity configured correctly and set up everything so you can deploy to your phone. But I promise you, when you get it deployed to your phone, this is the most rewarding thing. So I would try it, and I'm going to show you a demo, but keep in mind I'm just going to continue from the scene we had, actually the VR scene. I'm going to adjust it a little bit, and this should actually then do the trick. And so then you have seen Unity, both VR and AR both marker-based and markerless. So these are the first steps, keep that in mind. Alright, and here I've loaded the Burton Memorial Tower, the VR version with the XR rig. And what I'm going to do now is I'm going to create an AR foundation version of this. So I'm going to save this scene as final scene AR foundation. So this would now be markerless. Okay. So when we look at XR, you can see that I have all the AR stuff in here suddenly. So then I'm actually going to delete this and I'm going to insert a new session origin. That session origin actually gives us an AR camera. So that's that AR camera. And so that session origin is at 000. So we actually have some work to do. We actually have to the world, this would be crazy. So something like this would be 12 meters by 50 by 15. So what I would prefer is that we actually make it smaller. So let's just work a little bit with the scale. Keep in mind we are now doing AR. So let's just do 10% of all of this. So we have to figure out what we want to do. Do we want to just have a tiny version of it and look at it and walk around it? Or do we want it to be kind of like a building, relatively realistic? I would say we do a baby size version at the moment. So then we should actually make this even smaller. Cool. So now I'm kind of like happy. We have an AR session and we're going to get the AR, actually we have the origin and now we have this session. Okay, so that's the two things we need. Then we're going to go build settings. We're going to switch to Android, switch platform. And I have already connected my phone. So via USB, so then here, ta-da, there we go, cool. Last thing I'm going to double check is the player settings. That one thing I wanted to see, we have the AR Core build settings that came when I installed the other stuff. And here we are enabling AR Core as a plugin provider. So I switched from Windows where we had Oculus before. I'm now going to do AR Core. Cool. So that should do the trick, build and run. We're going to build. And here comes the app. Okay, for a second you could see how it was loading and there is the Burton Memorial Tower. It's pretty big. And we have the platform here. But going closer doesn't actually bring it a lot closer. It's really still far away. So we're going to continue and adapt the scale a little bit. So I'm going to just stop this. So building worked and all that, but scale is still pretty. Let's do a tinier version. So what I'm going to do now is I'm going to actually create a new 3D object that is empty. I'm going to put the reference image, the plane, and all that in there. And I'm going to just change the scale of that object. And then this is like one fourth of it. And so then I'm going to place this at 0, 0, 0. We're going to center everything. The reference image, I'm going to center everything relative to that. marker to that plane. So then this one goes out to 2.5 is what we had. And so we're kind of like getting it there now, right? So this game object, we're going to push a bit backwards, and the image is something we have to change. Going to bring the image out, and now we have a better way to play around with scale. So this should now be, so 1/4 is now a meter away. I'm going to connect the phone one more time, and we are going to build and run, build again. It's copy pasting it over, and then it's going to run it on the phone. And in fact, it is on the phone now, so I'm going to actually take the phone and place it. And now we do the initialization, and there is our tower, the Burton Memorial Tower. And now I can go closer, and tracking is better. And this is kind of like probably what we want. Kind of like we wanted to have it in the room. It's kind of cool. And you see both the tower and the reference image. We don't need the image marker tracking in this example. And yes, so the tower could be improved in terms of the 3D model, but as a proof of concept, we actually adapted this relatively quickly. So again, main point is scale. Paying attention to scale, really, that is the key trick. And then adjusting a few plugins here and there, and changing the platform in Unity, and then we have it.
In this video, I'm going to provide some first steps in Unreal Engine. I'm going to provide this overview. I need to say a few things first, though. The first thing I'm going to say is I am not super great at Unreal Engine yet. Most of my projects that I've done in the past, they were in WebXR and in Unity, so I'm quite fit with those two. Unreal Engine, we just had a learning group this summer also in my lab, and I'm beginning to learn more and more. So the Unity skills translate relatively quickly to Unreal Engine. I renamed a few things. You will notice that obviously with Unreal Engine things look amazing. An advantage that you will notice right away when I give you the VR demo is there's a VR button and you just press it and it works. So I just use I'm going to use the Oculus. Come on, Oculus, where is it? Okay, here we go. I'm going to use the Oculus Rift S. It's connected to my computer. Press the VR button and I preview any 3D scene. That's really cool. That's going to give you an edge potentially. And if you're doing the honors track, and one of the tasks I'll ask you next week, actually, when you do the 3D scene this week, if you want to do that, and then next week I'm going to ask you to turn it into a VR scene, and you're like, okay, Michael, is it really that? I just pressed that button there. No, you should also adapt a little bit for VR scale, and maybe some of the proportions and camera angle perspective, and think about ways of making it more immersive, obviously. But so anyway, I'm going to give you this overview here. One thing I want to also say, just like with Unity, if this is your VR headset, don't do Unreal Engine, and there's no need, and don't do Unity. I think if you're aiming for cardboard, my personal recommendation to you is just go WebXR. So follow my first steps in WebXR, and even though I show it in the Rift S there, I think it is actually relatively straightforward. With cardboard, I have more examples in my basic VR experiences lecture. So you can also refer to that. So in this one, we're going to go into the Oculus Rift S, so using VR. And the cool thing about Unreal Engine is, not only is there a VR button, no, the engine actually, the editor, really is available in VR. You can actually configure things in VR. You can do immersive authoring. So I'm going to show you how I start moving things in VR, and then I mean, the session where I had to continue longer, I'm using the starter assets there. If I were to do more, I could actually seamlessly switch between the editor and the VR preview, in which I can do immersive authoring. Now, I think that is really, really powerful and really cool. So something for you to explore a little bit, maybe. That's what I would encourage. I'm also going to show you AR. So I'm going to run an AR project that they have. Again, same tedious thing. Connect your phone via USB make sure that you kind of like get it connected there. I was struggling a little bit. I'm not going to show you all that. It was a little embarrassing. And it may change. It may not be relevant. Maybe things will be easier. So I figured it out in the end. I got it to deploy, and I'm going to show you how you can drop a few primitives in the studio here. And that's actually not a bad example. So I'm going to show you that in AR, markerless AR, using my AR Core phone, so on Android. They have plugins for ARKit, so you just need to enable the right things when you're going to develop for AR with Unreal. It's possible. This is like a teaser. Can I make an advertisement? So later in week 3, when we really spend more time on AR, I'm going to show you the Mission AR Unreal Engine project. So that's going to run on the HoloLens 2. That is really cool. So when we're talking about like you're going all in, so you're doing Unreal Engine, you have like a HoloLens or a Magic Leap, which I don't have, but a HoloLens 2 and you have Unreal Engine. So then you just download the 13 gigabytes of Mission AR and get it to deploy it on the device, and it's going to be a cool experience. So I'm going to show you that. I can't wait to show you that. But don't jump there now. Follow this video. These are your first steps. So if you feel like you want to work on my exercises as part of the honors track and you want to choose Unreal Engine, this will help you. This video. It would be too complicated if I when I go through the honors track to show you like how you can do this in WebXR or in Unity or in Unreal, whichever one you want to do. That video will take forever. So this is your reference video, and so well. We're doing okay with time, so let's get started. I'm going to go into the Unreal Engine, which is probably going to load a little bit, and then I'm going to show you how we can use the Rift S for VR, and then after that I'm going to do the AR version, the project that they have there. It's pretty cool. Welcome to Unreal Engine. I'm showing the editor here. I created a new scene with the starter content, so it comes with a couple of things. Quite a few things, to be honest. So then it also gives you a scene, which they call map, and we have a couple of what you would call Unity game objects, our actors here. So these are in what is in Unity the hierarchy. It's called the world outliner here on the right. So we have the chair and the other chair. We have a bit of the floor, and we have the table there. And then we have the tools, the typical gizmos and the tools, the shortcuts work that we are used to from from Unity, and so all that's kind of cool. All right, I'm going to bring in a cube just to show you a little bit of how this would work. So we're going to bring it in, we're going to rotate it like to 30 degrees or something, and we're going to scale it down a little bit just so that we are kind of like happy. And then I'm going to let's just change the material. Let's do a brick kind of material. That's kind of cool. And now I want to show you something that I find even cooler, and that is that we can actually go into a VR mode. You were eyeing this the whole time. I am going to click it. Here we go. We are now in VR. We're actually at the kind of like interesting location. So I have a little bit of manipulation tools. In fact, I actually have more than a little bit of manipulation tools. What I'm doing right now is bringing up the scene. And now I'm actually going to edit things a little bit further. And so I can change the scale if I wanted to. So I can just scale the whole thing just with the controller in VR. I could also scale individual things. What I want to accomplish is I actually want to get it on top of the table. So I'm going to bring up the menu here. And oops. And then we are going to go into tools, and one thing I wanted to show you is a flashlight, which is pretty cool as a tool, like in a dark scene. Imagine working in VR in a dark scene. So and then we're just going to disable this, and we are going into the gizmos. Actually, that's what I want. I want to rotate. I'm going to click this object. Actually, I didn't want to rotate, but okay, here we rotate a little bit. And you know what? We're going to make it more like the diag. And now we're going to translate it.
So I don't use this too often. So scale, this is translate is down there. Did I not pick it? Okay, and we're gonna actually bring it right in front of us. I moved back a little bit, but I can also move the scene. So it's kind of comfy, and that's actually what I wanted to show you. I mean, there's a lot more that you could do, and we could actually like really edit this object, and I'm just gonna actually show you what happens. You can bring in different kinds of menus, select an object to view the details, and then you have all the editor things here about that object in the view, and you can pick a different object, and you kind of like have the inspector here, which is pretty cool. So I'm not gonna leave VR. I think I wouldn't actually really go through all these things, but here is our new scene. Through all these things in VR, but here is our scene, the way we've edited it. And now, if I didn't like anything, I could just like undo a lot of the things that I did and just restore the original content. And so whether or not you edit it in VR or just in the desktop doesn't make a difference. In fact, there's a seamless blend between digital and immersive authoring in Unreal Engine, which I think is a plus. And it gives you a rapid preview, so that's actually very good for prototyping. So that was using Unreal Engine with the Rift S, and that's pretty cool. Now I'm going to show you, as I said, an AR experience, so using AR Core markerless AR with the Unreal Engine. And to make it clear, I'm actually going to start from the experience. So we're running it on the phone first, and then I'll walk you through how that experience was created. And I'm keeping it at a rather high level, and it's intuitively explained. This is not really like a step-by-step, that demo is going to take 4 or something minutes. It's not going to be too detailed, but it's the first steps, okay? And if you are committed to learning more about Unreal Engine, really check out a lot of their content. They have lots of good documentation. So let's just focus. Let me give you this demo, and let's see whether you think Unreal Engine could be something for you to explore in this course. And there we are. And now I can like tap, and it'll place objects or a randomly chosen geometric shape, put that in the room. It also works like placing it. It does some basic plane detection. When it actually detects a plane, it'll work. This one is funny. So I'll show the debug, and what we can do here is show the planes. It's not as fancy a rendering as we have seen in some of the other software, but it kind of works. Tracking is obviously, well, this seems a bit off. But overall it's kind of okay. And this one is quite cute, unclear where it landed. And then a couple of other things we can do. One thing that I show is the origin. This is where we were as we were starting the app initially. So we were really facing like this way. This is like almost our exact location when we launched the app. And so we can see this. We can hide the debug. And that's all we can do in this app, but it's a good starter project. And now let's inspect this a little bit, how this is actually done in Unreal Engine. All right, here we have the mobile AR project in Unity. It's actually empty the way it looks, it's empty. So it's not empty. It has, well, this map, which is empty. It has a little bit of configuration stuff, which is not so interesting. It has blueprints that really give us information. So one thing you will see is when you actually launch this, it'll show you not much, but this menu first, where you can press the Start AR button, and then once it launches the scene, it'll put the scene in there, and then you will have this menu here, which you can show and hide depending on whether you click this or not. So that's like that. And the other thing that we can look at is actually in the placeable So this is when you will see in a second when you spawn new objects. This is a blueprint. So and this one will basically create a new mesh at the determined location, and we are going to use a different blueprint to determine that location, and that is actually in the game framework when we do the, well, it's not in here, let's just set up the basics when we do a new kind of like object spawning here. So you have a world hit test function. So basically when the user touches the screen, we are converting from the screen to world. We're figuring out through some kind of like pipeline where that 2D coordinate, actually what that translates to in the 3D scene, we're going to spawn a new object at that location, and this is going to be our object that we are then going to spawn, and that creates that what they call a pin in this example. And so last thing I wanted to show is actually, so there's, after a bit of setup, there is seamless integration in Unreal. So I've now connected my mobile, my phone, my AR Core enabled Pixel 3. I press this, and what it'll do is launch a process to actually deploy things to the phone. And this is going to take a while, but it's building the executable, it's packaging it up for Android, and then it's actually going to launch it on my phone. But I've walked you through the basics of the project. There is one last thing, which is this AR configuration, which is a session in AR Foundation, for example, in Unity. So that sets up some of the basic elements for the AR settings, and now it's actually deploying it to my phone, which means like very soon we can actually launch it. That basically is my overview of what the project looks like in Unreal. So my whole goal for this honors track was to lay out a framework so that we can learn together. You choose the platform, you choose the toolkit. There might even be new toolkits out there than what I've covered here. And that's fine, you're totally allowed to do that. But I want us to approach this a little bit more with a, yeah, let's work with some of these technologies. And so the whole point of this video is to walk you through, well, a little bit of this mental model that I have for this honors track. Maybe provide a little bit of a rationale for some of the decisions that I made. This is the one that works in the residential program, and I hope also for you online. So, okay, this is my preface to everything that's coming. And now I'll walk you through a little bit of the structure of the honors track and how we will learn together and how we will engage with each other. So, let's get started. So course 3, as you know, is structured into these 4 modules. And first we learn about just generally development approaches, and we're learning about how to build our XR development toolbox. And then we are actually making this jump from 2D to 3D. Then we focused on VR development. We're learning about basic and immersive, so more advanced, let's say, VR experiences, how to design and develop them. We learn about AR, both marker-based and marker-less AR, some of the differences. We also learn about how to go from mobile, so handheld AR, to head-worn AR. So I'm covering all these topics. And then there's special topics. So these are things that are out of reach for us in the honors track. And so now the honors track, I said there is additional content, and we're going to do these exercises here. We're going to do a 3D scene. And this one will be modeled after actually a sketch. I wanted to sketch out what you have in mind. Sketch it out on paper, and use this as a template. And I'll tell you more about how, in each of these exercises, I'll tell you more about how to approach each of these. But then we take that 3D scene, and then we're doing a version of it in VR. You shouldn't start from scratch. You should actually build on what you've created in the 3D exercise and then take it into VR. Maybe add a little bit to it to make it more immersive. That would be great. And then you take that 3D scene and you take it into AR. I think it's better to start from the 3D scene and do it, put it into AR with some of the tools. So with Unity and Unreal, it's a little harder to go from 3D to VR and then to AR, because you have to remove things and remove plugins, and it's, I would just say this should be our starting point. So we're doing these 3 scenes, and the relationship between them is, in the 3D scene, you're building this, you're starting with a sketch, and you're pushing yourself a little bit, but don't go too hard on yourself. A 3D model and a few things around it. I'll provide some guidance on how to approach this. Could be like a movie scene, but make it simple. The examples I show are in the first steps. For example, in Unity, I'll show you, I was inspired by this Burton Memorial Tower. It's a tower that is here. And then all I do is play around with a photo of that, so that's in some sense my sketch. And I create this tower, mostly in 3D primitives, but these are the first steps. And then if you were to follow this approach, like take something that inspires you, a single object, the next step would be to actually replace it with a more, well, higher fidelity 3D model. But I don't do that in the first step, so it provides some resources for you to go there, but that's something you will explore in your own time. And then you're taking this 3D scene that you have created, and then you're creating a basic virtual reality version of it. So that means you're adding camera, so a camera rig, and maybe you're enabling teleporting and things like that, and that would be then more immersive. And then optionally is actually teleporting and also some interactions. The interactions are the hard part. You can probably do, you can get away without a lot of coding if you don't do interactions, and if you're modeling your interactions after some of the examples that are provided by Unity or by some of the toolkits, like when I say Unity, so AR Foundation and XR Interaction, they come with examples, so that would help you for, so the XR Interaction part would help you for the VR solution here. And Steam VR, for example, has an example scene, and then Mixed Reality Toolkit has also great examples, increasingly also for mobile, initially mostly HoloLens. And so then I'm already talking about AR, so you're doing an AR scene, and then you're learning about marker-based or markerless. So here, this is more optional, because I don't know exactly what kind of device you have. You probably have a webcam, so you should be able to do the marker-based AR version. And if you have a latest generation smartphone supporting ARKit and ARCore, then you can also do markerless AR. But so it's one of these. You're not doing all of these all the time. And so at the end of it will be a peer review. We're providing feedback to each other, and you submit what you have. You submit the things that you are proud of. You submit the things that you have accomplished, and I'll provide more guidance on how to submit those things. And then you will receive a review or multiple reviews, and I'm also going to ask you to review other learners' work. And so this peer review process is very important for us, and I think it will enrich your learning experience. So I was thinking, rather than now me sitting down and putting together like a million different prototypes, and I have a lot of those, but they are in the right places. You will find them in the right places. What I do here now is guide you through how you should use the resources that are provided in this course. And there are some links to the second course. The second course is more focused on design, but the second course starts out with laying the larger framework for how to approach XR design and development. So what doing XR involves is a good lecture there. So this lecture in course 2, it's not part of this course, that's why I have it with this rectangle. That lecture is going to be a useful resource. And I'll incorporate some of the key elements from that lecture here, but this is not supposed to be a lecture. This is supposed to be a guide through the honors track. So you will find also additional information, obviously, and materials in the Building Your XR Development Toolbox lecture. So that is actually, you just probably saw this, it's in this week. And then you are probably already thinking about making that jump from 2D to 3D. And there were lots of examples in there and steps in there. And I actually provide more in-depth examples for designing VR and AR experiences, and especially for WebXR. A lot of my examples are A-frame based. I think it's a great tool for us to learn online in CodePen or in Glitch. And I understand, however, that maybe you came here because you feel like, you know what, AR VR is all about Unity or Unreal, and that's what I want to learn. When I say building your XR toolbox, so building your VR toolbox. I talked about all these things in a lecture. And so think of the honors track as really like making the path through this, so from 2D to 3D, so it's the 3D scene, then designing a bit of VR, so that's your basic VR scene, with a little bit of basic interactions, but some of them are already optional. So travel and selection, I'll make them optional, you will see that. And so advanced VR interactions, many design, you will touch on these, but again, more like as optional. So we cover it, but we definitely make sure that we have the fundamental stuff covered. So these, out of the VR toolbox, you will practice these. I mean, we learn about each of these, but practicing really the fundamentals. On the AR toolbox side, we're really making this jump from VR to AR. And so you learn a little bit about this, but a lot of this happens behind the scenes. If you're going for a marker-based approach, so that would be down here. So with ARJS, for example, in WebXR, that would fit the bill. And you can also, if your smartphone supports marker-less AR, so AR Core and AR Kit enabled, you could do it with WebXR. And otherwise, I would say we'll just do the marker-based AR, and you don't have to do the markerless AR. You can't. You don't have the technology, and that's fine. So one of those two is what I require, and then just a little bit of it. The interactions, again, are the hard parts. I'd like to push you to give it a try, but to make it through the program again, these are more on the optional side. So at the highest level, you have a few choices to make. You choose the platform, so WebXR, Unity or Unreal are the platforms that I think we should be working with. You choose a toolkit, so I'll have a little bit more information on that, and you find in the respective lectures. And you choose a device, and you choose essentially two devices, one for VR and one for AR. So on the XR platform side, WebXR, Unity, Unreal. That's our main platforms. And then it's a toolkits question, because I don't want you to start from scratch. And so in the lectures in this week, you learned already about the toolkit, some of the options you have. I mapped each of these toolkits on the left to the respective platforms and supported devices. And so if you're like unsure whether you have this cool idea for this marker-based AR scene, can I do this? How would I do this? But I want to use Unity or I want to use WebXR. So refer to that, and also maybe consult in the forums and see how other people are doing. Look at other people's projects. We have galleries, so you should be able to get a lot of inspiration and also information beyond the lectures that I have covered. So throughout, I said it's about systematic process. So we'll actually learn about going things, and this honors track is really focused on that. Okay, so course 2 in the XR MOOC specialization covers like this and jumps occasionally into AR, VR with some of the tools I provide, but you're not really developing with these technologies. So this is the course where we'll spend most of our time here. And so I would obviously like you to do the entire XR MOOC specialization. You'll cover everything, and you'll be able to go from paper, and you learn about rapid prototyping techniques to really like jump quickly up there. But making this jump from here to 3D is our first important step and is our first important goal. So, content and interactions. So think of it as going in your project, going from lo-fi to hi-fi. I mean, your project consists of 3 scenes: a 3D scene, a VR scene, and an AR scene. So you're going to start out with placeholder content. I'll recommend to you that you do that. Then you're going to take it a little bit into more polished content. So this could mean just applying color, material, and those kinds of things to the primitives, or actually working with 3D models. I think you would learn a lot. There are lots of free 3D models out there that you could work with. And then we are going to try to add implicit and explicit interactions. So for example, a user should be able to look at an object, gaze at least. If you have a cardboard and you don't have like the fanciest device, then gaze interaction should be possible. And then this would fuse, and then it would click. And we want to change the visual appearance. We want to think about feedback and also this idea of affordances, that a user, so some visual cues in the interface. That's more like the design language now that I'm using here, but something you will be familiar with if you have completed course 2, to guide the user through the interactions.
And we're going to translate in this course mostly like, what does this mean actually in terms of like, bam, a list of content things, a list of explicit interactions, and a list of implicit interactions, okay? So things you would do in the 3D, VR and AR scenes is actually like, kind of like, check off this, check off that. Oh, let's do environment. Maybe physics, maybe I skip physics. And so that's cool. You should definitely do some sound. I encourage you to do sound, not just visual. And then, well, maybe we do a little bit of menus and HUDs. I'll leave this up to you. I won't push you too hard there. And then explicit interactions. You really explore a little bit like a lot of implicit, like with the camera, with the markers in AR, with something like bringing some objects or some environmental feature in view in markerless AR. So we're going to explore this. We're not going to work with, too much with GPS location, other than maybe the fact that you might be designing for a particular area in your home or workplace or wherever you take this course. So as you work on these honors track exercises, please keep in mind that you should keep it simple. So don't push yourselves too hard. Nobody's going to judge you. We want to keep it simple. We want to learn, okay? The best way to learn is to actually keep things simple, and then when they work, you can make it a little bit more, a little bit harder, a little bit less simple, let's say. You should focus on learning a systematic approach. That is actually my focus when I teach you this. So really the method. That to me, the results will be okay. If you follow the method, if you demonstrate that you understand what I'm saying in terms of systematic approach, working with placeholders first, and doing the sketch on paper first. If you follow my method, you will have good results. You implement using a platform and toolkit. And that way you learn about AR, VR. This course is not focused on learning a particular tool. You use the tool to learn about these technologies. That's how this course is unique, potentially. And then you actually you should take the AR, VR case studies. We actually will learn next week and the week after. You will see two case studies contributed from students that I've worked with, so not my own work. So really, we'll learn from these two case studies from two of my students, Kara Daly and Shweta Rajaram, and you should treat them as a guide and an inspiration maybe. But still try to keep it simple. Don't go crazy, okay? And then treat my first steps. I provide first steps for each of the platforms. Treat them as a reference. Consult them. I do provide more steps when it comes to WebXR and A-Frame. I suspect that the majority of us will go that path. These tools are changing like daily, and so the WebXR specification is evolving, but I understand the direction in which it's going. I'm a little involved in some of this, previously working with Mozilla, and so I think this will be the right way to spend my energy by providing you more examples in WebXR. And then Unity and Unreal, they're really good. They're providing additional resources. As we speak, they're probably working on some of the videos, and so they're making frequent updates, and those materials might be more up to date. So you should refer to the platform and toolkit specific documentation and their examples. I think learning from their examples would be really great. So you adapt the code for your own project, and you learn from other students' methods, tools, and results. That's what the peer review, why it's there, why it's so important. So this is how I think about this honors track. I really hope we're going to have some fun. I really hope the way I've designed it, the way I've thought about it, I made some good decisions. This will give us enough flexibility and freedom, and you can work with the devices you have, and you can choose the toolkits and platforms that you want to learn about. I look forward to seeing you in more of the lectures around the honors track. I'll guide you through each of the steps in more detail. This is my general overview. So thanks for watching this.